Welcome everyone to the Java 25 launch stream here from the Redwood Shores campus from Oracle. Almost.
In the Bay Area.
In the Bay Area.
He forgot where he is, jet lag.
Yeah.
Can you believe it?
All right, so Java 25 has already been launched, and we're going to be talking about all that has been released in Java 25, but we're also going to be talking about what's been in Java 22, 23, and 24 today.
Without further ado, folks, we have prepared something very special for you today. We're going to have live coding, we're going to have conversations, and of course, deep dive presentations on the features that are upcoming in Java 25 and more. So specifically, we're going to cover on performance updates, what's new in the Java language, of course, what's the impact of Java in AI, because let's face it, AI is everywhere, and Java is influencing AI as well, so we'll have our part there as well. And of course, it would be boring just to be the three of us today, and we don't know all the topics that well, so we got some guests from the JDK team, from the community, so that you will be entertained by more people that are going to bring their insights on how they're using Java in their day-to-day life and more. And without further ado, among those guests, I would like to mention that there's Paul Bakker from Netflix who's going to tell us how they're using Java beyond Java 21 at Netflix at that scale, imagine folks. And then we're going to have like our own Dr. Deprecator. I know you love him, Dave, so stay tuned for when he arrives here to tell you more on what he's planning to do, what it is have been deprecated in Java 25, but also what's coming in the future. So, Nicolai, is there anything left?
Yeah, so we also want to hear from you. So we have some polls prepared on a few different questions. You'll see those pop out throughout the stream, so feel free to answer those. We're curious about that. We're going to take some time to chat and to look at your answers. We'd also like to see you in person. This isn't quite possible now, but we will be able to do that at Java 1 in March next year, when mid-March, when Java 26 releases. So yeah, we'll hope to see you then. Java 1 also takes place in the same building whose name I already once didn't get out right, so I'm not going to try to repeat it. But we'll be here in the Bay Area. Okay, and without further ado, I think it's time for Billy to get started, and then I will see you in a couple minutes. Have fun, Billy.
All right,
Bye.
thank you.
See you soon.
All right, everyone, so we're going to get started by going over the performance updates, and for that, I'm going to have Mikael Vidstedt, one of our senior engineers and managers on the performance team. So with that, Mikael, I will leave it to you to cover the performance updates.
Thank you, Billy. So, it's been 6 months since we released JDK 24, and it's been 2 years since JDK 21, and we've been busy behind the scenes improving all the different areas of the JDK. That's everything from libraries to the VM to garbage collectors, Git compilers, the works. And over time, those improvements tend to add up. So, of course, only you can really look at what that means for your specific application. But in order to give you a feeling for the kind of improvements we're seeing, I'd like to walk you through a few of the things that we've done and seen. So let's start with one of our favorites, Spec JBB. So it's an industry standard benchmark, and we use that for performance, to drive performance work, but also to verify the performance work we do. The industry benchmark here produces two different scores. It's what's called the critical JEPs, which you can think of as a latency score, and it's a max JEPs, which is more of a throughput score. And we're seeing them here visualized in the graph. It's comparing JDK 21 to 25. And on the latency side, you can see that the improvement is roughly 10%. And on the throughput side, roughly 5%. And what you should know about this benchmark is that even a single-digit percent can be very hard to come by, so we're pretty happy with this. But it does get more interesting when we add in the previous releases as well. So what I did here is to add all the scores all the way back to JDK 8. And what you can see now is that on the latency side, we're seeing a pretty spectacular 113% improvement, and on the throughput side, 31%. And this is the kind of improvement, maybe this is the most interesting part, right? This is the kind of improvement you get by just deploying on the latest JDK version. There's no need to rewrite your application. There's no need to even recompile your application. Just deploy on the latest version of the JDK. But that's benchmarks. What about real apps, I hear you ask? Well, I have you covered. So let's have a look at Helidon. So Helidon is a cloud-native, open-source Java framework for writing Java microservices. And what we're seeing here is a comparison, again, between JDK 21 and 25 for two different flavors of running Helidon. So in both cases here, we're seeing an improvement in the order of 1.7x, so 73% on average improvement for this specific application. And that's pretty impressive if you ask me. That's real resources and ultimately money saved. So JDK 25 includes a lot of interesting features, and I'm going to talk through a couple of my favorites. So let's start with compact object headers. So what you should know about objects on the Java heap is that every object has a small header associated with it. We need this in the JVM to track information about the object. So for example, its type or its class, and we have some other bookkeeping information as well. Now, you should also know that most objects are actually fairly small, so in the order of 64 bytes or so. And what that means is that the header can actually be a significant overhead in these cases. So with compact object headers, we are reducing the size of that header to 8 bytes. And that frees up a lot of memory that can be used for actual data instead. Now, benefits here, if we again look at the SpecJBB 2015 benchmark, include 22% less heap space used and 8% less CPU time. And we also are seeing the number of garbage collections go down by roughly 15% because smaller objects means less churn and less garbage collections. In JDK 25, this is still an opt-in feature. It's not on by default. So if you want to try it out, use the Use Compact Object Headers command line option, and do let us know what you see. We're interested to hear. Another favorite feature of mine is the AOT work that we've done. So in JDK 25, there are a lot of features and improvements that aim to improve on startup time, or for that sake, time to peak performance. And in particular, the ahead of time or AOT functionality that we have worked on in the context of Project Leiden. Now, I'm not going to go into detail here because I know that Billy will be talking more about this in this stream a bit later. But in a nutshell, what AOT does is to allow you to run the application in a training run, and we snapshot the JVM state, not the application state, but the JVM state, so loaded classes and things like that. And store that in a file that can be then used at subsequent runs to speed up startup time. And what you're seeing here in the graph is, again, Helidon, the startup time, and we're comparing the case of not using AOT with the new AOT functionality. And we can see that it's actually 3 times faster to start up. And more improvements are coming out of Leiden going forward. So we're pretty happy with that. I could literally talk for hours about all the great performance improvements we've done, but I don't have hours. So I'll sort of leave you with this slide. This is my cherry picking a few of the different areas we've invested time in and improved things in. Maybe it's worth calling out the crypto instructions or improvements we've done. And I also want to call out the auto vectorization thing. So auto vectorization here is work that we do in the JIT compilers to automatically leverage vectorized instructions in the CPUs without you having to even think about it. You just write normal Java code and we do that work of leveraging the vectorized instructions or SIMD instructions in the CPU. In total, between JDK 21 and 25, we saw over 3,500 enhancements, not all being performance, but a lot of them were. And these are the, again, improvements that you get without having to recompile your application, just improve or update and deploy on the latest version of the JDK. And please do take JDK 25 for a spin and let us know what you see. We're very interested in hearing from you.
Thank you, Michael. That's really interesting hearing about all the performance updates that have come in Java 25, as well as what's also come in Java 22, 23, and 24. Like you said, sometimes some of the biggest improvements you get is simply from updating and doing nothing else. Now, it's not just performance updates a lot of developers are going to get between 21 and 25, but also a fix to virtual threads. But before we get to that, do you want to kind of recap what virtual threads are, just in case people are familiar? I know for my job, no matter how many times I talk about certain things, it's always going to be someone new who may be unfamiliar with it.
Absolutely. So virtual threads is something that we introduced in JDK 21. Mm-hmm. They are, on a very high level, very lightweight threads, right? Yep. They look and feel very much like normal Java threads, but they are very lightweight. And one of the key benefits is that they're very easy to use, and especially in concurrent scenarios, concurrent code, right? So in the past, if you wanted to really scale up and make sure that things were really performant, you basically had to resort to asynchronous coding patterns. Mm-hmm. And what virtual threads allows you to do instead is to just write very simple synchronized blocking code. It looks blocking. Yeah. But then in the runtime, we take care of making that all asynchronous and work behind the scenes.
Yeah, no, that's really nice because like for someone like myself, I've never really fully groked reactive code. And then I remember doing a presentation at an organization that does a lot of reactive development. And even they were still kind of running to some of the they had like the coding model down, but even the operational aspect of like, oh, you had some sort of error happen, and then trying to trace that back, you know, to what actually went wrong was sometimes pretty difficult. So virtual threads kind of help with that. You can kind of get that same horizontal scalability. You can get reactive code, but you can also still write it in that imperative style.
Indeed. And the other good thing is about virtual threads here is that we've made sure that all the normal Java observability and debugging is working really well with virtual threads as well. So it's really a win-win, right?
Yeah.
And also I should mention that these are very scalable, right? So instead of like normal Java threads, they're relatively lightweight, but you still probably like you hesitate every once in a while, should I create one? Yeah. Virtual threads, on the other hand, are designed to be in thousands or even millions, right?
Yeah.
They're very extremely lightweight.
Exactly. You're not supposed to pool virtual threads. They're an abundant resource.
Exactly. That's right. Yes.
So that said, there was one issue though with virtual threads that we kind of knew about, but it was kind of brought to some prominence by Netflix when they released an article called "Dude, Where's My Lock?" So do you want to kind of maybe talk to that?
Yeah. So this does become a bit technical, but basically
we love technical.
That's good. That's good. Yes, I love technical stuff as well. So basically, the way that virtual threads are implemented is that they do still run on. They get scheduled on. We call it mounted on a platform thread, right? A normal Java thread. But they can be descheduled or unmounted and show up on a different platform thread. But the point is that they do get scheduled on and run on or in the context of a platform thread, right? And we did have some issues in JDK 21 that basically made it so that when they were mounted, if you performed some specific operations, the virtual thread effectively got pinned. It got stuck, if you so will, on the platform thread.
The big point was it would happen in either a synchronized block or a synchronized method that, as you said, if a virtual thread encountered a blocking operation, it would stay pinned to that platform thread.
Exactly, that's right. And part of the reason for this is that like our normal Java locks, the synchronized blocks, they were implemented in such a way that they actually sort of interacted with the platform threads, not the virtual threads. So if you did do a synchronized block, it got associated, if you so will, with the platform thread. And that meant that if you then blocked somewhere, that virtual thread was now stuck on the platform thread.
Exactly.
And the problem is platform threads are a finite resource, right? So that was a problem.
But the good news is that it is now resolved, right?
Exactly right, yes. So with JEP 491, synchronized virtual threads without pinning, we now have resolved that issue. So the locks, if you so will, are now associated with the virtual thread instead, and that means that we can now unmount that and free up the platform thread for another virtual thread instead.
Perfect. And so, that came out in Java 24, and that means, of course, also that is now available in Java 25. And as you can see on screen, that was with JEP 491. Released in Java 24. So that is going to be very interesting. We'll also be talking a bit more about virtual threads when I actually have Paul Bakker on later on about also some of the other improvements that have kind of come between Java 21 and Java 25 to virtual threads and other areas as well. So thank you very much, Michael, for that update on both performance as well as that fix to virtual threads. All right, so I am actually going to be continuing on here in just a few moments. We're going to take a brief break, but I'm going to be talking about a new feature coming to JFR in Java 25. That's going to be very interesting for potentially finding issues like what happened with virtual threads, but also other ways of doing diagnostic and profiling information. So don't go away. All right, welcome back everyone to the Java 25 launch. Okay, I am going to be talking about updates that came to JFR, or JDK Flight Recorder, in Java 25. But before I get into those, because I know from personal experience of talking on JDK Flight Recorder a lot of people still aren't taking advantage of it. So briefly, JDK Flight Recorder is a diagnostic and profiling tool built directly into the JDK. And so what's really great about that is you don't have to go out and download some sort of other binary or do some sort of complex configuration to get started using with JDK Flight Recorder. It is directly built into your JDK as long as you're using a hotspot, JVM, or derivative, which I imagine most of you are. But also what's a key advantage to the JDK Flight Recorder is, just like its actual namesake, is that it has an extremely low overhead, sub 1%. Because if you're going to be running a flight recorder on an actual plane, you can't have that being taking up a huge amount of energy because that's going to affect the performance of the plane. Well, that is the exact same case with a JDK, or with the JDK Flight Recorder, or JFR. It can, if you're going to be running this in production, you want to have it be minimizing the impact on the performance of your application. Otherwise, you're only going to be running it at specific times. So by having it sub 1%, you can always have it running out in production, collecting diagnostic and profiling information, or if something catastrophic happens, information to maybe recreate what was actually happening causing this issue to occur. All right, so in Java 25, there are two major improvements added to JFR. The first was JEP 518, JFR Cooperative Sampling. And what this basically is it kind of improved the stability of JFR and also kind of reduced the performance impact. I'm not going to talk too much about that because really it doesn't affect how you use JFR. It just kind of works better for you. What I will be talking about, though, is JFR method timing and tracing, which is going to allow you to do, as the name suggests, the ability to time and trace methods. Now, one of the key advantages to how this works, though, is it's all done through simply configuration. And we're going to be kind of looking at that in a few moments, but you're not going to have to make any sort of code changes to take advantage of that. So let's go ahead and actually take a look at how this would actually work. Let's end that presentation. There we go. Sorry about that. All right, so I am going to be demonstrating using the simple Spring Boot Pet Clinic application, a very popular demonstration application that was put together by the Spring team. So if I was to copy that up into here, so just to kind of explain everything that's actually happening here. So to use JDK Flight Recorder, one way of doing that is by when you start up the Java application with Start Flight Recording. Now this is the new part for it here. This is the method timing. And in this case, I'm going to tell it to be timing all references to the org Spring Framework data JPA repository, basically the find all repository for whenever I'm making calls to our database layer. And then also, this is a new feature that was also added in Java 25, report on exits. So basically, this can be a really good way if you're doing some quick performance tests and you want to quickly do some analysis on it. I can run the application, kill it, and then quickly get back a report on it. So let me go ahead and run this application. Okay, now it is up and running, and let me just do a little bit of work on it as well then. But first, let me show you what I'm doing here. All right, so here is the Spring Boot Pet Clinic application. Let me make this a little bit bigger. And I'm just going to kind of click around and just do a few things here. So find owners, do some work, just kind of simulating a little bit of workload and behavior. Okay, that should be enough for this simple test. All right, now if I kill this application, I immediately get back this report. So this is being generated by JFR View. This was actually added back in JDK 21. And what's really nice about this is a good way from your command line to be able to do some analysis on it. Now this is a little bit difficult to read, so I'm going to make this a little bit easier to read for us by actually looking at it in a notepad. So if I was to just run this command, going to run JFR View and put the output into the method timing report. And so here it is again, and a little bit better formatted. It's a little bit easier to read. Oh, wait, that is an old report. Let me show the one that I just did. We will revert that. There we go. There we go. This is the updated report. So we can see we have a few executions. We can get the average time it takes to execute as well as the minimum time and the maximum time. But this can be a good way to find, if there's some sort of slow performance occurring, like there's an unusually high maximum time. That can also be a good thing that maybe sometimes things are taking way too long to run. All right. So one thing that's also extremely nice about this, as I mentioned, this can be all done through configuration. And also this configuration, though, is that you can actually even have it on a live running application. You don't actually have to stop and restart your application. So, sometimes, you're going to have an application out there running, and all of a sudden you're going to encounter some sort of issue. So here I am starting up the application again without having started JFR. And if I do JPS on here, I can see here that the process ID is 36259. So if I was to take this here, this command, oh, that's not what I wanted to do. If I just take this command and then pop in that process ID, run this again. Okay, so now the JFR is actually running to do the method timing, or in this case, I'm doing method tracing, and I can do find order. And so basically what I am doing in this is just trying to find all the methods that are actually interacting with the data layer from my application. So once again, I just did some brief amount of work. There we go. And then you can also see through here how I can then actually get that information back out of the application. And now I will quickly do this to do analysis on this. Oh. And all right, and I'm actually already running the new Java 25 release that was just released a few hours ago. And now if I was to open this up here, here we go. So this can give me a trace of all of the calls that have been made to my data layer. All right, so I hope you're very interested in this, in the new JFR updates. There's a whole lot more coming in Java 25, and for that, I'm going to hand it over to my colleague, Ana-Maria.
Thank you, Billy. Really cool demo, by the way. Folks, we're going to go now a little bit into the language features, and I want to talk to you through the flexible constructor bodies first, a finalized feature in JDK 25. Now, probably many of you know constructors in your Java classes. That's something trivial. That's something that you work with all the time, and it's known to all of you. But let's take, for example, the hierarchy of the dessert and the cake that extends dessert situation. In this case, the constructors are being run top-down in our inheritance hierarchy. The first one that's going to be like called is going to be object, but that's going to be like a silent call, then dessert, and then cake when we're going to do a new cake, for example. The way that this is being thought in Java is in order to preserve integrity of the object being constructed and to have this call of super here as being the first thing in the object that is subclassing the superclass. In this case, we're talking about cake. So going further, what are the corner cases when working with constructors in inheritance hierarchies becomes a little bit more complex? So, for example, in the case of dessert, we need to have like validation in constructor. It's fine. The superclass is good to have like a validation exactly next to the instantiation of fields in the constructor. That's kind of like okay. But what if we need to add a little extra validation for our cake class? So, for example, a cake has a number of servings. It's okay to go through the validation that it's going through desserts, but of course we want to make sure that it spends some time in the oven as well. So in this case, in order to preserve the integrity of what we're doing, but also add some validation to our fields for our class cake, what we end up doing most of the time as developers, we end up writing this validate method, or whatever you want to name it. We're doing the inline validation of the parameters that we want to pass to the superclass constructor. And then maybe we extract this to the lovely private static int helper method. Well, it's a great helper method, but unfortunately, if we want to test this, it's kind of cumbersome. And yeah, it's not very feasible to go further in this kind of way. So what we needed as developers, and would have been nice to have, is like to have a feature that gives us more expressiveness when we're working with constructors in Java, but also keeps the integrity that we're used to when working with constructors in Java in hierarchies of inheritance. And of course, no changes in the JVM. So can we have them all? Yes, we can have them all. We can have all the cake. So in this case, we got flexible constructors bodies feature now finalized in JDK 25 after 3 rounds of preview. We got feedback. That feedback was refined. So now we get a way of instantiating constructors in the inheritance hierarchies by having first a prologue before the super call and then an epilogue after the super. So what this means in a nutshell, it means that now we are allowed as developers to have something before the super invocation of the superclass constructor. Let's take a closer look on how that it goes for the dessert. So now the call graph, the hierarchy of the call for the dessert and the cake is becoming something like this. So then we have first the prologue and then the epilogue. Take a look at the code a bit. Now the code, well, how it looks like, well, we can still keep the same things that we had in the dessert, but now we can add our validation before invoking super of the superclass. And of course, we can also have this for the flavor of the cake also before super, so that we can preserve even more the integrity of the object that we're trying to build. That's pretty cool. And probably some of you are wondering like, hey, but you said in that slide a little earlier that, let me just go back a little bit. Too much. This one, yes. You said the prologue is limited. What does a limited prologue mean? It means that you can have in that prologue exactly whatever you want, except for the object that you're currently working with and to be there in the code, and actually have like working with the written fields of the object that you're trying to build in that constructor. Well, folks, I'm looking forward to your questions about this new feature of Java, and I am heading over to Nicolai for more features regarding the Java language. Nicolai?
Yeah, thank you, Anna. Right, so we just seen flexible constructor bodies, but there have been a few more additions to in the last couple of Java versions, and most of them are under the rubric of paving the on-ramp. But so that's compact source files and simplified main, module imports, and launching modified programs. But I want to look at them through a different rubric. So as often when accessibility gets better, that actually improves lives for everybody. So this is not just a feature that you would use to teach beginners or to learn as a beginner. It's also something that is really handy for more experienced developers. So let's do that for a moment. So I recently was at a talk, Java Zone, and I learned that Wikimedia has a stream of all the life changes that happen on Wikipedia, on all of Wikipedia, I guess. I think on all of Wikipedia. Don't quote me on this. The important point is, this is a server-sent event stream that just keeps pushing out stuff. And why don't we consume that and do a few things with that? Okay, so you can already see I'm using simplified main here. I just have a main class. And yes, I'm using IDE because I like using IDE, but I'm just gonna use it for code completion. We're gonna actually run this from the terminal. Why don't we get started with that? Even though it doesn't do anything, we might as well run Java main Java. There we go. Nothing happens as expected. Okay, so let's start doing things though. Specifically, we want to build an HTTP client to connect to that, right? So let's create a new client. HTTP client, new HTTP client. There we go. And now we need a request. So let's, not a car. So let's build a request as well. There we go. Okay. So we're going to have a new HTTP request. We need a new builder because we need to configure a few things. Specifically, we need to configure what to connect to. And that's going to be the URI that I have up there, because no way am I going to memorize that one. So I cheated a bit and put it in here already. Now, we need to have some meta information. Otherwise, Wikipedia is not happy with us. Specifically, we need a user agent. And that user agent needs to spell out who we are. So let's say we're JavaX demo, version 0.1. You know what? This is version 1.0, isn't it? And then some contact information, which corporate soldier that I am, I'm going to use my Oracle email address for this, because I'm not going to dox myself here, oracle.com. Not that you couldn't find my email address on my website. But anyway, okay, cool. So, great. So we got the user agent now. And we need to configure the stream. So there's going to be an accept and an event stream. Okay, there we go. Now we have our request. And you can see that the new HTTP API is very, it's not that new actually, it's a couple years already at this point. But it's much better than the URL based stuff. So we can now send this request asynchronously. And there we go. And now we need to define a response handler. That means wait, where is it? HTTP response. Oh, right. That's actually a good point. But the imports here. So we have a few imports already, but that's just way too detailed. I have something better for you. Let's use a module import. Let's say import module Java net HTTP. There we go. Okay. That should give us all of that. And now we have the response here. Good. So they have the inner class body handlers, and we're just going to tell it how to transform this. And we're just going to return this all into individual lines. And then this is going to be done asynchronously. So we're going to get new events as they happen. So we're going to take the response. We're going to go through the body. And then for each line in there, we're going to print. And we're going to use the no IO print line. So that finally, all the people making fun of us for use system out print line can finally stop doing so, please. Okay, we need to sleep for a while on this main thread, because otherwise the program is going to end immediately. And there we go. Okay, let's, we need to catch that exception. So let's just be very general. Oh, sorry, not catch. Throws exception. There we go. We're just going to not care about exceptions here. Let's run this for a second. And now we're seeing output. Okay, so what do we get? Every block starts with an event, what kind of event this is. And then there is an ID, and then there's data. And this data is JSON. Okay, so what do we want to do now? I think the next step would be to start working with that JSON. Now, at the moment still, we do not have a JSON library within the JDK. That might actually change soon, but not in the immediate future. So instead, we're gonna use Jackson for that for a while. Okay, so let's start by processing each line. That's the method we're gonna use to process each line. And first, as I said, we're gonna isolate the JSON. And as you've seen, that these that they start with like this data colon block. So we're gonna look into that. I'm gonna say if the line, if the line does not start with the data. People are chatting behind my back. I can hear you guys. Okay, so let's get the event. Line.substring. We're going to just remove the data colon. There we go. Okay, and this will bring us the actual event. Now let's print this. IO print line. Let's print the event. And then we're going to use this for that. This process. There we go. Okay, let's run again. And now, oh, I think we deleted the thread sleep. That we definitely still need the thread sleep. There we go. Maybe run a little bit shorter, only like the full 10 seconds. And, oh, what did I do wrong? I did something wrong. Oh, yes. The space goes elsewhere. There you go. Okay, that should do the trick. So everything that is not data we release. Okay, there we go. Cool. So now we see the JSON. Now, as I said, what we want to do next is we want to start parsing that JSON. But since I want to show you JDK features, and this is not yet available within the JDK, and we are using JSON, I'm going to cheat a bit. I'm just going to copy paste the method here that I'm quickly going to walk you through. So first of all, we're using an object mapper here, and we're using as I said, JSON. So we have to add an import, and then the mapper. Where's my key cursor? There it is. Okay. Right. So we're going to import everything from JSON. We're going to use the object mapper here, and then we can down here use the object mapper to parse the string into a JSON tree. And then we get the type. So in the JSON, there is an attribute called type, and it has either it's new or it's an edit. That depends on whether it's a new article or it's an edited article. And then we're going to print. If it's a new article, we're going to get the sub-element length, and then we're going to print the value of new. And otherwise, we're going to get length and print old and new. So I don't want to go through the JSON in detail, but you have to trust me that this is actual stuff that is present in the JSON. And now if I would actually use this instead of, there we go, instead of just defining it, we could actually see what's happening. So let's say parse event here. So now we're parsing that event. And that did not go. Oh, it's printing directly. It's not returning anything. Fine. Okay, there we go. Okay, we start seeing things. So we now see that some articles changed their length. This is one, like this one, for example, which got a few lines shorter, actually. And then we have new ones. Occasionally, this is a new one. We just printed the new length. Okay, so you can see we can, like, just in a couple lines of code, without like any ado, right? Like this is just, again, I'm using IDE because I like code completion, and some of the other more involved features. But I'm just writing text and then running this on a terminal, right? You can see that you can do this in a wide variety of environments. You don't necessarily need to have an IDE for that. Okay, now, what I want to do next is I want to show you that, let's say we work a little bit longer on this, and this example gets too large, right? And at some point we realize, okay, this is one long file. It's not that long now, but let's imagine it's too long. It's getting too unwieldy. We would like to apply a little bit more software development and just throwing everything into the same file. Want to start splitting out. Okay, so let's do that actually. So far, I've only used main.java. And now I want to start creating a new Java class. Come on, there we go. Okay, so let's call this, I don't know, wikistream. And we can now throw our code in here. So let's pick this code up. There we go. And let's just put it here. So here now, we do have to have the class wrapper, because only the main class can be the one that doesn't have a main class around it. Only that file does not need the class. This one does. So we're going to write a static method. I will call that, let's say, from Wikimedia. Oh, right. And it's going to return something, right? No, it's not going to return something. Because we pass in what's supposed to happen. So I just copy paste the code. Let's copy over some more stuff. In this case, we need the URL. So what's interesting here is, once again, you're going to use module imports. Oh, wait, that's the wrong place. My bad. Okay. We're going to use module imports just because they're new and they're nice. So what I'm doing here is I'm telling the compiler to please make available all the public types, the top level public types in the exported packages of this module. And as you can see here, my code does not need to be in a module for that, right? My code isn't. And you can do that with all the modules that the JDK offers. and all the modules that your application has. So far, we don't have any, so we can use the JDK modules. And now what you notice here is it doesn't know the URI class anymore, which might look weird because, wait, isn't that was all we needed here, right? Just the net import. The reason for that is that if you have a simplified main class, you get import module Java base, I should say, for free. So that's the base module. That's all the file I/O and collections and datetime and all of that is in there. So there's already a lot in there that you can make use of, and you get that import for free in a simplified main class, which makes it easier to get started. But here we need to put it add it explicitly. Okay, now this is all good except for this little process thing down here. So let's pass a consumer here. So basically we might want to do this consumer, and then we consume strings, right? That's called process. There we go. Okay, and now we should be able to grab this here. We don't need any of this anymore. We're just calling the wiki stream from Wikimedia with this process. Okay, so accidentally, by the way, out of reflex, I realize right now I didn't start from the terminal actually. Just out of habit, I just hit the run configuration. So I want to prove to you this actually works from the terminal. So this does not work anymore. Now it doesn't work for a specific reason because where's the dependencies, right? We don't know where the dependencies are. So we need to add those. So let's add the class path. And because it's the class path, we need to do this still. So I have a folder deps here that I can show you, which contains the jar files. Now, in a real-life scripting situation where you get those jars from is a little bit of an open question. That is not very solved right now, at least not with onboard tools. Use something like JBang, other tools, it's easy to get those things. With onboard tools, not that easy, unfortunately. So basic, but magic happened. I have the jars here, so I can run them like this. Okay, so this works. And I want to tell you all the things that happen, right? So this is a bunch of things that happen at once that seemed ludicrous just a couple years ago, which is I'm telling the Java launcher, not the compiler, about one specific source file, and then I point at a few dependencies. And what does it do? It looks at the source file, and then it sees it has dependencies, right? Like import com, fast XML, whatever. It notes that clearly comes from a separate jar, from a separate source file at least, or binary. And because I give them the class path, it looks into the class path, and it finds it there. So that's good. That's where it gets the dependency from. I'm also referencing the class wikistream. And because that class also doesn't have like a package name or anything else, it seems to be in the default package, which is just like the top level folder here. So it assumes that it will find wikistream in the same folder. And it does. It is indeed there. And so that's why this works, right? And if I don't do this, you would get the compiler as expected. Let's just call this wiki, right? And then it happens what you would expect what happens, which is that, that was without the dependencies. Which is now we get compile errors, right? I mean, for obvious reasons. So, but the interesting thing is that the launcher, we're still not talking about the compiler, will find all of this information, all of these source files and dependencies based on where we start with the main class. Okay, now we've done that. What we can do now is we can do different things. Like we could develop a few more features, which is something that we may get around to if we have the time. But what I want to do as well is I want to give this project a little bit more structure. Say we have a few more source files, and also we're very annoyed, like I usually am, by this class path. The thing that I know most about the class path is the quotation marks and the slash asterisks. It's like it's a directory. Find stuff in the directory, please. And we can absolutely do that with the module path. So we can just say the module path, because it does actually understand directories, is look for dependencies in this folder. And we try this, and now it doesn't work because it finds modules in there, but it doesn't know that the dependency modules still work as they usually do. So we have to do a little bit extra work. So again, I would not do this in this project because it's very small. But let's say we would have like a slightly larger project, and then we would give it some structure. So let's start with making a module called wikistream, and then fill in the module dependencies. Sure, let's do that. There we go. Requires, the transitive part, I think we can get rid of that here. And we already know that we also need the Java net HTTP module which contains the HTTP client. Okay, so that's interesting. Let's see what happens if we do this now. So the thing is, this starts working, but the error we get is that the unnamed package is not allowed in named modules. That means this top-level default package that we're using here doesn't actually work in a module. So unfortunately, for this not quite so minimal structure there anymore, we do give it a package name. Now you might wonder, why would I start doing all of this, right? Why would I go through so much effort? Oh wait, not demo, that's a bad name. Let's go to Wikistream. Why would I go through all this effort, right? At this point, why not just use a build tool? And I think that overestimates, or underestimates, I should say, the complexity that these tools bring, and that they're only really helpful. Not helpful is the wrong word, maybe, but they only unfold like the biggest potential if you actually want to ship something. But it's very feasible to just do stuff locally, to automate things on your own system, and then all of these steps will still help you have a properly structured project without necessarily needing a build system if you don't want to use one. Okay, so we going in here now. Let's see, what's this error complaining about? It's not public from outside the package. Why would be outside the package? Oh, this one doesn't have a package declaration. Package Wikistream. Import. Oh, this one doesn't have. Oh, right. Yes, of course not, because it doesn't have a class yet. We still need to put the class around here. Now that we have a module, so now that we have a package, we need to put a class around. Unfortunately, that's a little bit sad, but I think we can handle with that. Deal with that. I mean, that's the trade-off we're making for getting a little bit more structure. Okay, good. That's all that. And then let me see, class main package, right? The package declaration, so it goes at the top. So I'm doing this all very manually, right? What the heck? You could totally do this with better IDE support, but I want to pretend like I'm not in IDE, as I mentioned a few times. Hey. How to type? Wikistream. There we go. Okay, good. So now I think we're getting there. Could not find. Oh, right. Yeah, so we need to go at the path, right? Like we changed where it is. Wiki stream main. Oh, and we stole the letter. I think there we go. There we go. Now it works again. Okay, so what do we do now? Well, we did again like a bunch of stuff actually, right? We have what starts to approach a more normal project structure with packages, and we could have deeper package structures. There's no reason to just have this flat in one package. We could totally have deeper package structures. We could start using visibility modifiers, as we already have dependencies. With module info Java here, it becomes really handy. We just have to launch with -p and point at the folder, which will then pick up all the dependencies. So as you can see, these new features that came together here are really not just there to teach this to new students, although that is their primary intention, but it really also helps more experienced developers to just put something together that works without having to commit early to something like an IDE or a build tool or something along those lines. And yeah, so that's it for this set of features. I think they have been worked on quite diligently in the JDK in the last couple of years. And I felt like it's also been very well received by the community. And here to talk more about that is Shah and his guest, Ted.
So as we celebrate Java 25 arriving today, it's also important to celebrate the importance of the Java community in terms of the role it plays to keep Java vibrant, but also ensuring that we get feedback from you as users to ensure every release meets your development needs. And today, we're very lucky and fortunate to have Ted M. Young here from the Java community, an active member in the ecosystem, an individual that cares so much about inspiring other developers to become better versions of themselves, but also bringing students into the mix. And so Ted, welcome to joining us for the Java 25 launch today.
Yeah, thanks. It's really exciting.
Yeah, so you've been so involved in the Java community. What is really keeping the heartbeat of Java going from a community standpoint?
So there's lots of social media that LinkedIn and Blue Sky talk about sharing what they're learning, sharing new things that are coming out. User groups and conferences. I've been going to a bunch of conferences this year, and user groups are really the core of the community. They're what where you start out and then you grow and then you say, I want to do more, I want to speak more, and I want to talk more and get to know people, and you go to conferences. And so it's a really strong part of the community.
And so there's where a lot of those best practices and use cases that are coming about, even specific to Java 25, there's a lot of buzz and conversations specific to the new sets of features.
Yeah.
But who are some of the individuals that really speak to the value of Java? Can you talk a little bit about the Java Champions program?
Yeah, so there's a bunch of them. In fact, Blue Sky, if you're on it, there's a way to tag Java champions. So I'm always seeing in my stream, it's like, oh look, there's a Java champion. Let me take a closer look. And these are people who really feel strongly about it and want to share what they've learned. Folks like Dan Vega and other folks who just love to share, right? And that's very much like me. There's something about sharing that we both get something out of it, and everybody else who we're sharing it with gets something out of it.
Yeah, and so there's only so much we can do on the Java team. Of course, we have a lot of engineers putting in a lot of blood, sweat, and tears to make every release as rock solid as possible in terms of new features to accelerate developer productivity. But as you said, it really is the ecosystem, the community that offers a lens into the possibilities of what to do with Java. But one of the dimensions is the OpenJDK community. What are your thoughts about OpenJDK community, and how do we get more developers to participate?
Yeah, so there's a bunch of mailing lists. So I'm on them, and what's really nice is you sort of see people ask the deeper questions, like why is it this way? This feels awkward, and so it both provides a way to understand the thinking behind some of these features, why they're implemented in a specific way, maybe not to everybody's liking, and then provide also that feedback cycle that's so important in software development, right? If without feedback, how do you know you're on the right track? How do you know you're solving people's problems? And so what you want is that feedback cycle. You want to get those different points of view. And yes, there are going to be reasons where you may not like it, but here's why. And for me, yeah, there may be things that I wouldn't have done it that way. But understanding the deep history that Java has, right? We just celebrated the 30th. I mean, oh my gosh, 30 years is just amazing.
Right, and so oftentimes we'll get the question, and I oftentimes try to quote Brian Getz, who's our Java programming language architect. He will see a lot of comments come in from the ecosystem with, why can't you just? Right. And that why can't you just question is so hard to sometimes answer, because all of the things that we have to factor in to ensure Java is not just compatible with previous releases, but also ensures it meets the needs of developers who are really trying to use it in terms of edge use cases. That balance, becomes more exposable when you participate and actually see our language decisions in terms of what we're trying to do, or sometimes why we chose not to make a certain decision. So I always encourage developers to, as you do so often, is to come to OpenJDK, sign up for those mailing lists, see development transparently live as it's happening to get that input going. But
yeah, and
what else would you say?
There's not just sort of backward compatible, which is so important and incredible feature that you can take something you wrote 20 years ago and run it on a current JVM, but also the incremental development that we're seeing. So looking not just to the past, but also looking forward. How do we get to where we want to go and get there in such a way that works, that is manageable, that is understandable?
Yep, and all of that feedback is important, from individuals like yourself, other companies giving us input. We just want to thank individuals like yourself and everyone that's contributed to Java 25. But speaking of Java 25, we have 18 JDK enhancement proposals. Yeah. Oftentimes we'll get the question, what's the most important feature in the release? And we as developers all have our likes and our features that we are most attracted to. So I think it really is incumbent upon the type of development you're doing. For Java 25 specifically, what is compelling for you in this release?
So I think there are two areas. One is, so I want to say that the JEPs, the enhancement proposals, are super readable. Like they're not some esoteric specification language where, like the RFCs and other things that you might read where it's impenetrable. It's really readable. And I really encourage people to, as they come out and as they progress to candidates and through that process, that Java developers read them, because they're really good, and they really tell you what's going on, and they give you a little bit of like, well, we did it this way, but we changed this, and we're doing it this way, but we're not doing it this way. And so that, I think, is everybody who's a Java developer should read the JEPs. And so the ones that stand out for me, the ones relating to concurrency, structured concurrency, scope values, that's really important because, especially now that we have virtual threads and all these kinds of ways to write our code in a performant manner, making that easier, because that's always been a bit of a struggle, I know, for me, and I've been doing this for a while. And so it makes it easier. And the other one is the compact files and the simplified way of defining things. So both helping people on board, because we want to get more people into the Java community, and making that first step easier is really important. And then, and Kai Horstman has written about that, another Java champion, about using Java as a scripting language. Like I know, I need to do this and sort some files or do some other things or process some files. So let me go write bash. And then how do I test that? Oh, okay, how do I test that? I don't know. Whereas if I can write it in what's my native language, my preferred way of sort of talking to the computer, I can write that in Java, and I can use my IDEs, and I can use all the tools, and that builds on some of the earlier stuff where you can just say Java and a file, and you don't even have to compile it. And so you don't get these stray class files, you don't have to create jar files, you don't have to do all this kind of stuff. You can just run it. And so the way that things build upon it is in the progression of Java has just been really incredible.
I'm glad you highlighted JEP 512, compact source files, and instance made methods. For developers who are just starting their Java journey, it really does take away some of the complexity of trying to understand some of the concepts.
All these little boilerplate thingies that are important later on, but you don't need them early on.
Right, but it's a stepping stone. So as your development, your expertise grows, you can add back some of those concepts in a way that's more understandable. But as you said, it's also very valuable for existing developers, because we want to make developers more productive, make code more readable, more writable, more maintainable. And when it's a smaller footprint of code that you have to do and focus on, it just becomes that so much easier.
And you can take something that's like, oh, I threw this together to do something. It's like, now I want to distribute it. Okay, now you can go into the next process, and you don't have to rewrite anything. You can take it as is and then compile it and ship it. And that, and again, the JEP talks about why we did it this way is because of that. And so really a lot of thought goes into these new features.
Well, you spend so much of your time working with developers who are just starting their Java journey. And just earlier this year, we talked about a little bit of progress we were making with a new initiative called Paving the On-Ramp, an initiative about ensuring not just teachers, but students who are just learning Java can onboard in a thoughtful and easy manner. Thoughts on Learn.Java?
Yeah, and so, so I taught Java back in the late 90s. So actually before Sun even had their
Wait, you're now dating both of us right now.
I got the Java ring to show for it.
Oh, let's see that. Java ring, all right. That's a memorabilia I think everyone wants.
Yes, and I had to create my own materials. All I had was basically the language spec. And so basically having not just a source, but like the source for a place to go for getting started with Java and learning about the stuff that I don't even know that I know anymore is really useful to have that one place that I can point people to and say, let's start here, let's look at these things, let's understand this curriculum, go through these examples to learn how to code in Java.
Speaking of examples, one of the interesting dimensions that we now have at dev.java is the playground. I know you've been diving into that quite frequently and often. Little comments on our playground.
Yeah, if getting started with Java, if the first thing you need to do is go and download Java, which is not difficult to do, download an IDE, it's not difficult to do, but all these things, like before you can even write a line of code, one of the things that makes a language attractive is how quickly can I write some code and see the result, right? Again, that feedback cycle is so important. So if I can type something in and hit a button and see it right away, that's just great.
So we've focused on this concept of participation, on contribution, on community, on feedback. And for us, our flagship activity to centralize all of that and showcase all of that is Java 1. We just mentioned that Java 1 is coming back in 2026. Dates have already been announced, March 17th through the 19th. You were just at the most recent Java 1 this past March in 2025. Why should developers come to Java 1 in 2026?
Again, it's the community, the ability to talk to people and find out what's going on, but also ask questions, right? It's, you can absorb some knowledge and get a sense of what's going on and what's where and what's coming up and what new things are out. And I remember there were some great talks in one this past March. Victor Klang and always gives a good talk. And I think the talks are the spark for the conversations, right? And I actually ran into Brian Getz. I was asking him a question that I encountered with some pattern matching thing, an instance of checks, whatever. And the ability to talk to Brian Getz, and other luminaries and people who wrote the stuff or designed it or architected it, there's nothing like it. And I got the Java 1, the Java ring at Java 1, and the early Java 1s were why I moved out to California from New York. Because that strong community, that sense of community, that sense of, I belong here. This is where I should be.
Right. I mean, it goes back to the ethos of what Java is all about. For sure, it's a technology that literally future-proofs so many people's careers and has so much opportunities for addressing the use cases of today and the future. But the real ethos of Java is really the people and the contributions. I'm looking forward to hopefully seeing you again at Java 1 2026.
Absolutely.
We'll be able to also celebrate the availability of Java 26 in 2026. Right. So, Ted, thank you so much for being part of our Java 25 launch today. And hopefully we'll have more people in the community galvanized around Java in 6 months.
Yep.
Well, that was interesting, and lots of topics being covered regarding the language features. Good thing that we started those polls early, Billy.
Yes.
So we have some results, I assume. We asked you folks to tell us which Java version you're using in production. And
I'm already using Java 25. I went out there and downloaded Java 25, so pretty earlier on when I was doing my JFR demo, that was actually on Java 25 GA, not EA. But yeah, what do those results actually look like? I think I was looking up at them a bit earlier. And so I think when I was looking a bit earlier, I saw nearly 50% of people were already on Java 21. I mean,
wow, congratulations, folks. That's amazing. That's good. It's going to be easier for you to migrate to Java 25 since you're already on 21. Well, and that was the next one that was there. Oh, yeah, I think there's some people that were using already Java 24/25, so they're like 12%, and I've seen a question in the chat, somebody asking, like, who are those people? Well, to my knowledge, the library maintainers usually like to be early adopters and like to go with the cutting-edge Java versions. But not only that, there are products that are interested in like keeping up with what's going on in Java, like to anticipate and to see how their product will evolve, will migrate when it comes to a newer Java version. So there are always like options there, like when to be an early adopter and benefits to be an early adopter. Let's say not just waiting for a vendor to have long-term support for a Java release. Yeah,
actually I think that's one of the things that's kind of interesting. It kind of came up recently in a discussion on the Java subreddit where someone was suggesting like, oh, let's just stay on, going from the quote-unquote long-term support release, this long-term support release, which isn't really a thing in OpenJDK, but we'll go with the colloquialism for now. But I think one of the things that's interesting is by getting on that 6-month release cycle, there is benefits on being able to use the latest features, but also getting to that point to where you're on that 6-month release cycle, it's about maturing your DevOps and your overall operational structure to actually being able to handle those updates that you get a lot of benefits from. It's kind of like, the benefit isn't just being able to, like, say, immediately using some of the pavement, the on-ramp or flexible constructor body, which is, of course, great, or the great performance updates, but having that maturity of being able to accept those updates.
Yeah, that's always good. Like, staying up to date is also great from a security perspective and many more other reasons. We also have asked you another question on how do you learn Java nowadays, because we're interested to know how you learn Java. We have our ways of learning as well. So Sometimes we're using coding assistants. We also have a coding assistant. It's called Code Assist. That has a couple of models for us to help us in like learning things or discovering things when it comes to debugging. But we are wondering like how you are actually getting a grasp of what's new and what actually you're interested in Java. Not necessarily new, but maybe remind yourself about Java. And we got some results there as well. Some folks said that, well, the majority said tutorials and hands-on experiments. Well done, folks. If you want to mention what tutorials and which websites are your favorites for tutorials, please drop them in the chat. We would be interested to know about those as well and know where you're getting your knowledge from.
Yeah, no, that is always great to, to go right to like, definitely share kind of how you're learning. Really great websites. Of course, there's dev.java, which is a great place where we continually update it, right?
Yep, and there's Learn.java for the beginners that they want to ramp up their knowledge about Java.
Yep.
Billy, but how do you keep up to date with Java?
For me, I think it's definitely a mixture. Probably, if I was to answer this, it would have been the JEPs or docs directly, which of course obviously makes the sense for our roles because we are having to keep up with the latest, and then we're often going to then be the ones writing those hands-on tutorials. But yeah, first read the docs, then I'm going to be going out there and kind of doing some hands-on to put together, maybe a simple code tutorial. So how about you?
Well, the same thing, but sometimes I also disturb, our colleagues, the JDK engineers, and why not? Because they're colleagues and they're working with us. Sometimes it's better to ask the experts. But you can also ask the experts if you join the mailing list and you have a question, but sometimes the easier questions can be answered by us. We can answer those questions as well in the chat. I know it's not that easy, but because there's a lot of comments and sometimes some heated conversations in the chat there.
I've been seeing this.
We're liking those. And I want to see like what's the next one. So we saw JEPs, the second place. No.
Videos or talks is
actually the second place. The videos and talks and conference. Oh, yes, that's great.
Yes. What kind of conference might be coming up?
Oh, well, weren't they talking about Java 1
I believe so. And not only that, not only is it a great place for the talks, but you can also occasionally see some of those actual experts yourself as well.
So you can disturb them as well, not just us.
Yes.
We didn't.
The people who really know what they're doing.
Yeah, obviously. But another point that I want to bring here is regarding the videos is that we recently have released a series of videos that are teaching you on how to upgrade to Java 25. So we're covering the features between Java 21 and 25 related to language, related to API, security. And Nicolai has done a dedicated video on how to upgrade to Java 25, which would probably very helpful for many of you. It's quite funny. So I invite you to go through that series and look at it. If you are interested in getting more reasons on why to be on Java 25, leave us feedback on that or leave us a question about how that would help you or not help you and how we can do better.
But yeah, that was definitely a team effort. I believe you also had a video on that road to Java 25.
Yeah, security, but that's like a...
Do people really worry about security anymore? I don't know. I hear it's like the...
we all need to have that small data breach, the oops email. Remember?
Yes. Oh, yes, I remember the oops email.
So, folks, I encourage you to watch those. Those are in a fun way, I would say, describing learning and upgrading to Java 25, but we're still capturing the essentials there. So, well, let's see. So conferences were the second place when we have the JEPs and we have AI-powered code assistants.
Oh,
amazing!
That worries me. What if people start using AI-powered code assistants? What are we going to do?
We cannot help every Java developer out there, Billy. We cannot scale at that level.
That is true. Okay, I guess that can be helpful then.
But folks, if you're using AI code assistants, maybe you want to drop also as well how you're using those code assistants and what you found useful in them helping you learn Java. It's very important to have a good flow in collaborating with AI to actually feel that you learned something and not just be, get that instant gratification that, ooh, I solved the problem, but in the next second you probably forgot on how things have been solved.
Okay. All right. Well,
more polls are coming. So keep an eye on that chat. Respond to the questions. We're going to be in the chat as well, responding to your questions, engaging with you. And now I think there's somebody else who's following up. Oh, yeah.
Yeah.
Nicolai.
Continue to post into the chat for any questions you have. We'll be there as well. And yes, that's right. Our colleague Nicolai is going to be coming up next a little bit more on Java 25. Take it away, Nicolai.
Yeah, thanks both of you. I really like the insight into how people, what version they're on, and how they learn as well. Now we're going to talk about updating Java 25, as the two just teased. And most Java updates are, like most of the code base, you will not have to touch, right? We know that Java's backwards compatible, but that doesn't mean that nothing changes. There's always like minor details and fixes and whatever. Some of those arguably, like this, for example, aren't even like, this is just a bug fix that happens. But you know, some people might depend on the old behavior. So specifically, file delete on Windows used to try to delete read-only files, which is now doesn't anymore. And a bunch of methods on the class file no longer accept trailing spaces because Windows doesn't. And then there's like a weird syntax I've never seen, which is backslash, backslash, question mark, backslash, which you can start paths with that apparently on Windows. And they are now correctly processed. So that means that the methods behave differently now because now they no longer are these, like, have observed these like mild bugs. So yeah. One other thing is definitely a feature, but that has a few compatibility implications, is that you can now, in a security file, security properties file, you can now include other security properties files, which makes it more maintainable or easier to maintain various different security configurations. And this is done with the phrase include. But that also means that include can no longer be the name of a security property, which arguably wouldn't have been a good name anyway. But yes, you might have to check that, or otherwise you will see the error, and now you know what you're looking for. One other thing is also, again, like more like definitely like a corner case, which is null checks in inner class constructors. Now, every non-static inner class holds a reference to the enclosing instance. And that reference is implicitly passed to the constructor, which assigns it to a field. That's not something you see in the source code, but you will see in the bytecode. And in the source code, you cannot pass null easily, but you can use something like reflection, bytecode invocation, or the method handler API to actually pass null as a reference to the outer instance, which you're not supposed to, and which would lead to a null pointer exception at some point anyway. And now that happens on construction. So what I'm saying is there are additional null checks there. If you find null pointer exceptions in something like inner classes, think back to this and check that if it's your source code, definitely make sure that null is not passed to, in that situation. But if it happens in your dependencies, you have a little control over after finding a bug and maybe offering to fix it. You can set a flag on the command line to not, during compilation, to not create those checks. Okay, another change, which goes a little bit into the direction of integrity by default, making Java as a whole behave more behave 100% predictable, is that in the past, annotation processors that were only existing on the class path, but were never actively somehow triggered or turned on, they used to just be processed, right? So the annotation process would be used to actually process annotations in your source code. That is no longer the case. You either have to use processor path, or processor module path, which arguably we should have all done in the past as well. So the annotation processor should go onto the processor path to make very obvious that it is processing your source code. But if you for some reason don't do that or can't do that, you can use proc with the new value full. So proc is an existing option, but full is a new flag that then activates this behavior that then the annotation processor is kicking in, even if it's only on the regular class path. But the first option, definitely the one I recommend. Okay, another update is CLDR. So CLDR is the common locale data repository, if I did put this together correctly. Prior to Java 8, I think prior to Java 7, not exactly showing the details there, Java had its own locale data. And then at some point, the Unicode CLDR data was picked up, which is better because it's better maintained and it's updated automatically from the point of view of the JDK, right? So OpenJDK doesn't have to do any work there. It just needs to occasionally update. That happened in Java JDK 20 and 22. And these version upgrades can bring minor changes in, for example, formatting or parsing. Specifically, non-breaking or narrow non-breaking spaces, which is something that nobody types on the keyboard, but is something that technically belongs into a properly formatted date in certain locales. And so the formatter puts that in now, but also the parser expects it. And that means that some formatting or parsing behavior will change when you're updating to either 21 or from 21 to 25. Lenient parsing will be able to help you there, but more on that later in the stream. Unsafe memory access is something that is slowly being faded out. And that means that for certain methods that are listed in the JEPs that you can see on the screen right now, you get deprecation and compile time warnings since 23 and runtime warnings since 24. And at some release in the future, maybe 26, maybe after, you will probably get an exceptional invocation even, and eventually those methods will be going away because they have been replaced by the foreign function memory API. You can already simulate that future now. You can set the flag sunmisc unsafe memory access to deny, and then you already get the exceptions today, and that way you can try this out. Okay, I'm going to quickly go through the rest. So this is the list of restricted methods. You don't need to memorize it, but this list does exist in the Java doc. It comes from JNI and the foreign function memory API. These methods need to be unlocked explicitly with either the flag enable native access or illegal native access. So if your dependencies use JNI, you will now see warnings that you have not seen before. They will soon be errors. So take a look at these options to unlock this. If you're using the foreign function memory API, then you should already start using this from day one. As Billy and Anna just alluded to, I made a whole video on all of this and more in more detail with more things that might be happening. So please check out that one prior to the update ideally, so that you can get an impression of what could possibly happen, although I'm pretty sure none of your applications are as broken as the one I use in the video, which literally collects all the mistakes that can happen. Okay, one more thing that is important that is going away is the security manager. And here to talk about that is nobody else but Dr. Deprecator. Why don't you come on? Hi.
Hey, Nicolai.
Hi, nice to have you.
All right. Great to be here.
Yeah, so the security manager. We've talked about this briefly in the past. What's going on there? What is it doing? And why are you taking it away from us?
Okay, well, so the security manager, I think, is a vestige of a very old architecture that goes all the way back to the early JDKs and applets. The idea is that you could bring in untrusted code from outside the JVM and outside the class path, download it over the network, and run it inside the JVM in kind of, people say a sandbox. That's not really a good term, but I think it's something that people understand. And the sandbox was what was enforced by the security manager. And that was an enormous problem because all the APIs had to be security checked. There was check permission going on everywhere. Bunch of complication in the JDK. But also, it turns out that nobody really used it. Right? So applets have been pretty much dead for years. In fact, applets are also being taken out.
Yeah.
That's future. Oh. I don't want to pre-announce that.
Okay. That's a JEP now, right? The deprecator,
there is
the removal?
there is an applet removal JEP. Yeah,
exactly.
Okay. But applets, basically people have stopped using applets years ago. There are a few other cases scattered around in the JDK where we would download code and say, oh, okay, you got to run the security manager in order to use this untrusted code. Virtually nobody does that anymore. So we're saying, okay, nobody's using this. It's a maintenance problem, so let's take it out of the JDK. And this has been a years-long effort on the part of the security team, and Sean Mullins, project lead in that, has marshaled that through. And it's just, it takes a long time to get rid of stuff.
So I think the combination there is interesting, right? So on the one hand, it is very unused, but that is true for other stuff as well, right? We often joke about hashtable and vector. That's probably also, well, in compiled code maybe not, but nobody writes code against it anymore.
Yeah.
But being not very used is not enough reason to remove something. It's also, as you say, a drag on maintenance, right? It's a continuous cost that the entire ecosystem pays, basically an opportunity cost of lack of further development because the security manager requires work.
Yeah,
did require work.
That's definitely true. Every feature we'd add, we'd say, oh, okay, does this need a security check? You know, do we need to call check permission here? Do we need to call do privilege here? Don't have time to explain why you need do privilege, but this is a long tail of bugs, which is add some code in the JDK, bug gets filed. Oh, you need do privileged here. Go back and fix it, right? So over and over and over again.
Okay.
I've done that myself several times. So none of that.
Which side of that?
Missing do privileged.
so fixing, right? but also causing.
But also, so we've taken out all the do privilege because they're not necessary anymore because that was a security manager thing.
Yeah. So what's the current state then? Current meaning JDK 25.
Okay. So there are still some security manager APIs in there. So you can call system.getSecurityManager, but it always returns null. So most programs will do things like, if they need to check permissions, they'll guard it with a null check on the security manager. So getting security manager will return null, so it'll just bypass those checks. But the fact is, if you do things like call access controller or permissions checks directly, those you might get some exceptions, like unimplemented, or it'll fail the permissions. And so there's a very small tail of programs that do that sort of thing. And so, but I expect that the vast majority of programs will not need to deal with this at all.
Right, so that means at the moment, basically, Security Manager turned into a bunch of no-ops, as you said. Like, if I call something, like nothing, either I get null back from the system, or it doesn't do anything.
Yeah, we expect that most things will be no-ops, but some things, like if you call check permission, we can either say, oh, okay, in the absence of a Security Manager, does checking a permission mean do nothing, or does it mean throw security exception? We actually decide to fail safe. There are some cases where we always throw an exception, because if your code is checking a permission and there's no security manager there to check it, having it pass the security, it may give you the illusion of being secure when you're not. And so that means you have to change your code. But we wanted to alert people that, okay, there's this exception here, which is we're not actually checking permissions anymore. So there is some things like that, and that is a migration issue for some people who connect directly to the permission system or the access controller system without kind of indirecting things through the security manager.
Okay, that means if that code is in a project that I control, then I need to update my code. Some of these, I'm not sure whether it's possible here actually, but some of these other features that are going away have flags that you can use to either restore old behavior or like basically fake future behavior, like I just described with unsafe. So if my dependencies use this that I don't have control over, is there any way for me to still make it work, or is the only way out to get a dependency version that is fixed?
Yeah, I think you need to get a fixed version of it.
Okay, yeah, that makes sense. Okay, yeah. So that's that on Security Manager. Since you are Dr. Deprecator, and we're riffing a bit here. Anything else you've recently been? Let's call it deprecating.
Well,
in my head, I know you say you're a surgeon.
Okay,
but wait, is it butchery? Is it? Okay.
No. No, I mean, the fact is, it took several years to remove the security manager. It took several years to remove applet. Now that is happening. Now
unsafe the same. Basically, it started with 9 and it's still going.
So it definitely is surgery, right? And the next thing is finalization. So we're still working on removing I would say the biggest user of finalization in the Java ecosystem is the JDK itself.
Okay.
And so in order to remove finalization, we have to remove all the uses. And so there are some things, unfortunately, in our APIs that said, oh, this cleanup method gets called when this object becomes unreachable, which is basically a thin layer over finalization. And so we're going to have to make some changes there.
Okay.
And so, but that is proceeding, but it does take a long time, because there's a lot of analysis that has to go on. When you do something like that.
Yeah, last time we chatted, you also mentioned that applets as well, like that there's actually a lot of the desktop code, I think, is tested, you mentioned, through applets. So also the JDK is a big user of applets itself as well.
Well, not applets directly, but I think that there was a test framework used for the desktop stuff, and that used applets, and so a bunch of those tests had to be rewritten before applet was used. So the desktop team did get beyond that. They are in the process. Or if they haven't already, I don't know exactly where it is, but definitely the removal of applet is going forward, and now they're removing finalizers. A lot of the finalizers are also in the desktop side, but there are other finalizers scattered throughout the JDK, and we still need to work on those.
Yeah, I think that's really interesting, because when people look onto projects like the JDK, that's at least what I did before I came so close to it, is you feel like, well, that's different from what we do. Like, we do like messy software development, but JDK is almost like a glorious different place. And I think you guys arguably work more diligently with more long-term plans. But we can also see here just some things. It feels like burn down charts and making architectural decisions that then have to be implemented over arguably a long time to just get through all the work, to just remove all the dependencies on finalization, for example, or stop using applets. So really just work through a chunk of just busy work that comes from making an architectural decision.
Well, this is maintenance. And Java's 30 years old now, and so we have a big code base. Some of it is actually still the original code, I think. It would be interesting to figure out if you could figure out which is the remainder. But if you have a 30-year-old code base, then maintaining it is a big responsibility. And so proceeding carefully with that is something we really value.
Yeah, and I appreciate that you're doing that so well. Okay. That's that on deprecation and the removal of features, or removal of mostly unused features, as we just discovered. And next up, we're going to go back to new stuff that you can then maybe remove in another 30 years.
I hope not.
Ana and Poonam are going to talk about that.
Hi, folks. Welcome back to talking about security. I mean, the guys have talked a little bit earlier. We'll see if they can remove those things so easily. I have here with me Poonam. who is helping the JEPs team. That JEPs, if you don't know, it's a security provider that is produced here at Oracle, and is very helpful to keep you aligned with the standards of security and many more. But I don't want to delay you with all these discussions. Poonam is here to tell us more about how it is to secure the future with the JDK features that are now available. Poonam, the stage is yours.
Thank you, Anna. Hi, good morning. Hello and welcome. I am Poonam Parhar. I work in the Java platform group at Oracle as a product manager. And in this presentation, we'll explore how Java security has been evolving in the recent releases from JDK 21 to 25. So we'll begin by discussing this security evolution, how it has been evolving, and we'll discuss key security features that have been implemented in recent JDK versions since JDK 21, and how those enhancements have helped strengthen Java platform security, especially against post-quantum threats. So as we all know, cybersecurity landscape is rapidly changing, with new threats emerging from advances in computing power and quantum computing. And with that, organizations' needs are also changing. They now need higher levels of security, compliance, and resilience to protect their sensitive data and also maintain user trust. And to address these challenges, the Java platform has been continuously evolving, with the introduction of new APIs, implementation of new cryptographic algorithms, and new security practices. Let's explore Java's security evolution from JDK 21 to 25, and how Java platform has strengthened its security against these emerging threats. First, let's take a look at a roadmap highlighting key security features from JDK 21. So JDK 21, which was released in September 2023, it was the previous LTS or long-term support release. JDK 21 established a strong foundation for Java security. 22, which came out in March 2024, it focused on increasing visibility into security configurations, and also it expanded cryptographic capabilities of the platform. 23 improved debugging capabilities of security subsystem, and also it added support for Mac OS root key store. 24 focused on preparing the platform for future security challenges by implementing quantum resistant cryptographic algorithms, and it also promoted secure practices with the disabling of security manager. JDK 25, which we are releasing today, solidifies these previous advancements by finalizing the KDF API and by adding support for PEM encoding. All right, let's begin with JDK 21, which was the previous LTS release. As I said, it had set a strong foundation for security. Its emphasis was on long-term stability, and it established secure defaults for applications running in enterprise environments. JDK 21 was the first release where we introduced enhancements for PQC, or post-quantum cryptography. The first one was Key Encapsulation Mechanism API, which was a building block for which is a building block for post-quantum work. Another key security feature that we added in JDK 21 was HSS LMS, which stands for Hierarchical Signature System, or Latent Macaulay Signature Verification Algorithm. It's a quantum resistant signature algorithm, and it was a key enhancement for subsequent post-quantum cryptography work that we did in later versions of JDK. JDK 22, it focused on increasing developer insight into security configurations, and it added new cryptographic capabilities to the platform. Enhanced security configuration visibility. So one of the key features that JDK 22 introduced was enhancing security configuration visibility. It added a new category, security for X show settings launcher option, and 3 new sub options were added for this category: properties, providers, and TLS. So this enhancement allows developers to easily display their security properties, security providers, and TLS configurations. And it helps in easily diagnosing and managing security configurations and allows developers to ensure that their applications are securely configured. Another significant enhancement in JDK 22, key tool and jar signer updates. As I mentioned, in JDK 21, we added implementation and support for HSS LMS algorithms, which is a signature verification algorithm. In 22, key tool and jar signer tools were updated to support this signature verification algorithm. Jar signer tool now supports verifying jar files signed with this algorithm. However, signing jar files with this algorithm requires a third-party JCA security provider. And key tool also supports this tool, supports this algorithm, and it can generate key pairs for this algorithm, again by using a third-party JCA security provider. This algorithm is a quantum resistant signature algorithm, and the support for this algorithm helps preparing the platform for future security needs, especially in the face of advancing quantum computing technologies. Moving on to JDK 23. JDK 23 continued its focus on enhancing debugging capabilities for developers, and it also added support for Mac OS Key Store. One of the significant features in 23 that we added was enhancing the Java security debug system property. This system property is used to enable debug messages for the security subsystem. And this property was enhanced to include thread and timestamp options. By enabling these options, the debug messages of the security system include thread caller and timestamp information. And this greatly helps in troubleshooting security events as it contains more detailed context about these events. And it helps in efficient development, monitoring, and troubleshooting of security issues within Java applications for developers. And I'm happy to report that in JDK 25, thread and timestamp options have been enabled by default. Another significant feature in 23, Mac OS keychain integration. A new keychain store root was added to the Apple provider, which means that now the Java applications can access system root certificates which are available on the Mac OS system. And this feature, helps simplifying certificate management for developers working within the Mac OS ecosystem. Okay, let's talk about JDK 24. JDK 24 focused on future security challenges, particularly those posed by quantum computing. And this release included major advances focusing on quantum resistant cryptographic algorithms and key management APIs. The first one, the first major security feature in JDK 24, key derivation function API. So 24 introduced a preview of the KDF API, and it's defined in JEP 478. KDFs are cryptographic algorithms for deriving cryptographic keys from a secret key and other data. And KDFs are crucial for generating secure keys, especially in post-quantum cryptography, and are very important for implementing password-based key derivation algorithms like Argon 2. Another major step towards quantum resistant cryptography, ML-Chem. JDK 24 added an implementation of quantum resistant module lattice based key encapsulation mechanism, or what we simply call as ML-Chem. Key encapsulation mechanisms are used to ensure secure exchange of keys over insecure communication channels using public key cryptography. And this has been standardized by NIST in FIPS standard 203, and it's defined in JEP 496. ML-Chem is a quantum resistant algorithm, which means it provides security against future quantum threats as well. For this algorithm, key tool has also been updated to support generating ML-Chem key pairs and certificates. Another quantum resistant cryptographic algorithm implementation, MLDSA. So it's the implementation of quantum resistant module lattice digital signature algorithm, or MLDSA, was added in JDK 24. As we know, digital signatures are used to authenticate identities and ensure data integrity. This algorithm, MLDSA, is standardized by NIST in FIPS 203, and it's defined in JEP 497. MLDSA, like ML-Chem, is quantum resistant, which means it provides security against future quantum computing threats. Key tool has been updated to support this algorithm as well, and it can now generate MLDSA key pairs and certificates. Significant change in JDK 24. JDK 24 disabled the security manager permanently with no way to enable it. And this decision stemmed from several factors. The security manager has not been the primary means of securing client-side code for many years, especially since the deprecation and removal of Java applets. And it has been rarely used to secure server-side code. It has been expensive to maintain, and that impeded other security enhancement work. Looking at the timeline, the deprecation and removal process for security manager began in JDK 17 with JEP 411, and JDK 24 now permanently disabled the security manager with JEP 486. And this change is expected to have no impact on vast majority of applications, libraries, and tools. And the security manager API still remains, but it's been made void, and it'll be removed in a future release. All right, JDK 25, which we are releasing today, it solidifies the previous advancements, enhancements implemented since JDK 21, and it enhances interoperability by introducing PEM encoding API, and it finalizes the KDF API. So PEM encodings of cryptographic objects, JDK 25 introduces a preview API for encoding and decoding cryptographic keys, certificates, certificate revocation lists into and from this widely used PEM format, which stands for Privacy Enhanced Mail format. And this format is extensively used for storing and transmitting cryptographic objects, especially in scenarios involving email and secure communications. So PEM encoding, with the introduction of this API, JDK now enhances have more interoperability with other systems and tools that utilize PEM format. It's a preview API, which is defined in JEP 470. JDK 25 finalizes KDF API, Key Derivation Function API, which was introduced in JDK 24. One of the key derivation function algorithms implementation, HKDF, is included in the JDK, and we plan to implement Argon 2 in future, which is another KDF algorithm. This API facilitates implementation of advanced protocols, cryptographic protocols such as HPKE, hybrid public key encryption, which combines secure key exchanges using KEM and generation of secure symmetric keys using KDFs. And as I said, it's defined in JEP 510. So to summarize, Java's recent releases have consistently enhanced security, offering great visibility into security configurations along with integration with native systems such as macOS. And we can see that there's a clear shift toward post-quantum cryptography with the implementation of ML-KEM, MLDSA, and with the introduction of building block APIs like KEM API, KDF API. And additionally, important security features are often backported to ensure secure Java platform across releases. And these efforts collectively underscore Java's commitment to security.
Thank you, Poonam. That was amazing for covering all these changes, all the security changes. Folks, if you have questions regarding security and the security changes, please drop them in the chat. We're looking forward to answering those as well. And we brought the water for Poonam because some of you noticed that would be good to bring some water to Poonam. So that's what I wanted to show, we have it here. But without further ado, keep in contact with us in the chat. I'm going to at some point respond to the many comments that you put there, but now I am looking forward to giving the stage to Stuart Marks to talk to you more about scoped values. Stuart, the stage is yours.
Thank you, Anna.
Hi, I'm Stuart Marks. I work on the JDK core libraries team, and as Anna said, I'll be talking about scope values today. So scope values provide dynamic scoping for Java programs. The idea is that at some point, a piece of the program can bind a value to a variable, and this value is visible to any to any method that is called on the call stack, and the value of the variable is the most recent binding that appears on the call stack. I'll have some code a little later that shows what's going on with that. It's a little too abstract. So one thing that scope values does is it allows a caller to pass implicit parameters to indirect callees. So instead of having to pass, for instance, context objects as explicit parameters to every method call, then something farther up the call stack can pass a parameter implicitly to somebody very deep in the call stack implicitly using scope values. Scope values replace many of the current use cases of thread locals. And scope values have gone through several preview JEPs and are now finalized in Java 25. JEP 506 is the finalized scope values JEP, and I invite you to read that to learn all about the detail of scope values. All right, so what we have here is a very simple example of the mechanics of scope values. So first thing is you call scopeValue.newInstance to create a new scope value. And initially, a scope value is not bound. And so you can see that if you call isBound, the return value is false. Now, if you call get at this point, you get no such element exception. So we won't call that at this point. Next, the method scopeValue.where allows the program to bind a value to the variable. So we say scopeValue.where SV hello. So it binds the value hello, the string hello, to the scope value SV. And then the run method takes a runnable or a variant of callable, which is a piece of code in which the value that has been bound is visible. And so if you look at this is a lambda here, and all it does is print the value of isBound, and then it gets the value of the variable. And so we see isBound returns true, and then the value is hello. Now afterwards, we call isBound again outside the lambda, and isBound has restored to the value false. And if you were to call get at this point, it would throw no such element exception. Now that's a little strange. I don't expect most people will call inline lambdas like that. Instead, what I'm going to do is set up a slightly more complicated example. We have a main method that calls 3 other methods. There's a print method that checks to see if the scope value is bound, and if it is, then it prints it out. And so main calls that directly. And then it also calls another method, 1, which binds the scope value to the string xyzzy, and then a different method, 2, which binds the scope value to a different string, plu. So let's look at the code that, so main ends up calling 3 different methods. And notice the path of the call stacks, each of the 1 and 2 methods ends up calling print as well. Okay, so let's look at the code that does that. First, we create and initialize a new instance of a scope value, and that's unbound. So there in the upper left, you see the main method. It calls print 1, 2, and then print again. And the output is in the lower right. And so you can see that in the first call to print, the isBound value is false. Now let's look at the method 1. It has a call to scope value.where and binds the scope value to the string xyzzy. And then as the run method, it passes scope value, the name of this class, scope value demo, and it just calls the print method. And then same for the 2 method, except that it binds the scope value to a different value, which is the string plu, and then it calls the print method again. So you see those calls to 1 and 2 end up calling the print method, and in those calls, the scope value is bound, but it's bound to different values. And so in the first case, method 1, the string is xyzzy, and the second case, it's the string plu. And so what we have here is a case where in the print method, the value that the scope value is bound to depends on how you got here. And that's what dynamic scoping is. So finally, when we return to the main method, it calls print again once at the end, and the scope value is no longer bound. And so this is the essence of dynamic scoping, where it, depending on what's on the call stack, will determine what value, or whether even what value the scope value has, or whether it's even bound. Okay, now let's take a look at a use case here. So it's quite common in Java to have a framework and then plugins that are separately compiled and separately developed that plug into the framework. And so you can see here that the framework can create a scope value and say bind it to a context. And so it calls scope value.where, and it binds the context variable to this new value ctx. And then its run method calls plugin to, say, handle a request. And so the plugin code has a handle method that takes a request and formulates a response. But along the way, it might need to do something like get the user that's requesting this. Now, there's no user parameter, and so it has to ask the framework where to get it. So what it does is it calls back into the framework. And in the framework code, how does getUserInfo find the user? Well, what it does is it looks up in the scope value to get the context variable, and then presumably the context has some kind of information about the user. So the user and the context that appear do not have to be passed directly to the handle method, and so it keeps the call signature very simple. But when the plugin calls back into the framework can find where it came from, and then it's basically a way for the framework to communicate with itself. Now, this is something that people would use thread locals for in the past, and we expect that scope locals will be used to replace many use cases of thread locals in this regard. Hi, Nicolai.
Have I ever seen you before?
I don't think so.
Okay. So yeah, Stuart, thank you. You mentioned thread locals a few times.
Yeah.
So how do they exactly compare?
Okay, so thread locals kind of seem like it's what you want, but there are a bunch of problems with thread locals, as we've discovered over the years.
When you get what you want, it's usually the first step to a problem.
Yeah, right. And so you can use thread locals for this, and in fact, many people do. But there is this problem, which is there are several problems with thread locals. So one is that thread locals are mutable. Mm-hmm. So notice if you look here, the way scope value is scope values are not assigned; they are bound. Mm. Okay, and so a thread local is assigned. You can call set and get on it. And so what that means is that, you have a bunch of plugins and stuff, and somebody says, I'm going to set it to something else. And so this is generally the problem with mutability.
Yeah.
Okay, so that's one problem. And so there's this general trend in Java to move away from mutability towards things that are immutable or unmodifiable.
Yeah, and it's not that conceptual ivory tower stuff, right? It means like code that is spread across a framework can just randomly set and read stuff, and that can make, That sounds hard to maintain. It's like a global thread local, but still global variable.
Right. Well, it sort of is. And so there's another problem with thread locals, which I think is more insidious, which is the lifetime of a thread local is entirely up to the code that deals with it. And so if you have a highly stylized case like this, it creates a thread local, maybe processes a request, and then maybe if you're lucky, it removes the thread local at the end. But if you're not extremely careful about that, then you might end up in a situation where these thread locals build up, and as different threads process different requests, the thread locals build up on every thread, and then you have memory leaks. And so you have to figure out, when is the right time to remove a thread local? And so scope values fixes that by saying we're binding a scope value for a duration of this call and everything it calls, and then when those return, the scope value gets unbound.
That's also important because even if you try to do with thread locals, I guess you can have unforeseen errors or some other mistake. Maybe even if you try to clean everything up, I think it's buggy because unlike this feels like a try with resources block basically, right? Where we have the language guarantee or API guarantee. This will definitely happen. There's no way that you can accidentally miss to unbound even in an exception case. Okay. I know there's a connection to structured concurrency. We don't have a lot of time, but like a 1-minute summary. What's the connection between scope values and structured concurrency?
Okay, so structured concurrency, you mentioned try with resources before. There's this idea of nesting of things. So in structured concurrency, which is still in preview, but we're designing scope values with this in mind. So you can fork tasks and join them within a method call. Okay, so with thread locals, there was this problem where sometimes you want to communicate this context information, except that how do you get the thread local over to something in a thread pool? Well, you kind of can't. Okay, you can fork a thread, and then you have to say, I want to inherit these thread locals, but then you have the cleanup problem again. Now, if the thread exits, they go away, but if the thread goes on and goes into a pool and does other stuff, those stick around, so there's a problem. So with structured concurrency, the idea is that we can fork virtual threads which can share the same scope values. And that's another reason why they're immutable. So you can fork a virtual thread, it does its stuff, and then when it's joined, then that binding disappears from that. And so the scope value stays within this dynamic scope of a single call across forks and joins in structured concurrency. So that's not there yet. That's still in preview, but that's the idea because you can see structured concurrency in the fork join approach in structured concurrency fits very well with scope values.
Right, so because structured concurrency is about making like a scope for concurrency.
That's right.
And then that will be meant like if the thread who starts that scope has access to a scope value, we know that one scope is in the other scope. Yeah, that makes sense. Okay, thank you very much, Stuart.
Okay, you're welcome.
We're now going to have a little break, and then we're going to throw it over to Nicolai to talk about stream gatherers. Okay, thank you, Nicolai. So we're here to talk about stream gatherers. This is a new API in JDK 24, and I didn't even. Give me a sec, because I totally wanted to show you through slides before we get. You know what? Skip the slides. We do it live. Okay, so stream gatherers. Let me riff for a second before I go to the code. Streams have all kinds of intermediate operations and all kinds of terminal operations. But one interesting thing is that Java streams do not actually literally have all possible terminal operations implemented. What they instead have is the concept of a collector. So the collector basically enshrines the concept of a terminal operation, whatever you'd want to do at the end of a stream, in the specific context of how the stream pipeline works with parallelism and everything. And they enshrine all this in an API, and then you can create your own collector, plug that into the collect method, then the stream API pipes in all the elements, the collector does its thing, and in the end it returns a data structure that then the collect call will also return. So that way we have a bunch of terminal operations, but we also have one ultimate pluggable terminal operation where we can put everything in that we want, all the behavior that we want. And now take that and apply the same idea to intermediate operations. So intermediate operations, again, there's a bunch of them on Java streams, but I think even more so than with terminal operations, actually, you will occasionally notice that something that you need is missing. Sometimes that makes a lot of sense because what we might need is very specific, but sometimes it's like windowing, which isn't that terribly specific, but it's still not there. And so the idea behind gatherers is, let's do the same thing that we did for terminal operations, for intermediate operations. Let's enshrine the overall abstract idea of what happens in an intermediate operation in a gatherer, let the stream API push elements in, and let the gatherer then have a downstream, which is the rest of the stream pipeline, available to then decide how to push elements into that. And so that's what the gatherer does. It gives us the chance to implement the intermediate operations that we want. And it comes with 4 building blocks. And I'm going to reveal 3 of them over time. And if I remember, I'll tell you about the fourth one towards the end. So the first and the only required building block is the integrator. So if you can see my code right now, I can actually show you, what, before we get to the integrator, let me just show you I'm using an existing gatherer here. So just like there's collectors, plural, the class that has a bunch of collectors that you can just invoke with a method call, the same exists here. So gatherers.windowSliding gives you a sliding window thing. So let's run this, and this time we're going to intentionally run it from within the IDE and over the terminal. And now, there we go. Okay, here we are. So we start with A, B, D, B, C, F, E. It's just a bunch of letters. And we run a sliding window of width 3 over it. And that means the next operation is going to consist of small lists of 3 elements each. And which 3 are those? Well, it's the first 3. And then it's that window sliding 1 element over. So it's the second, third, and fourth element, and then sliding over 1 more, and so on until to the very end, right? So this is what window sliding does. It's a gatherer that already exists that you can just use with the gatherers method. Okay, now let's actually start writing our own. So here I call it my gatherer. So let's call gatherer my gatherer, and then let's start with doing nothing specific. So this is a gatherer down here that I already copy-pasted into this thing first. So it only consists of an integrator. So we create the gatherer. We're going to make it a sequential gatherer, meaning we're not caring about parallel streams right now. And we only have an integrator. And the integrator is a thing that does most of the work that you want to do with an intermediate operation. It gets past 3 things. A state that we're not going to use for now, the next element of the stream, and it's going to also get a downstream, which is basically an abstraction over everything that happens later in the stream. And what this one does, very simply, it just calls downstream push elements, so the element goes into the rest of the stream pipeline. And so this is doing nothing, right? It's a no-op, so to speak. Well, it's transparent, I should say. So it does something, namely it pushes on the element, but it doesn't change the behavior. The input will be like the output, so we can see that here. Okay, now we can now start having it do something. So maybe for beginning, I'm going to re-implement something that already exists. Let's have a map function. Let's apply a function. And so then here, let's go here and let's have a look at the generics. So these gatherers become more usable if you carefully select wildcards with super and extends. I'm not going to do that here because it makes stuff a little less readable and also much more likely that I make small mistakes. So let's not do that. But if you write an actual gatherer for production code, you will want to think about where should I put an extends and where would I want to put a super. This gatherer comes with 3 type parameters. The first one is the input type. The middle one is the state that you will never want to expose. If you do, nothing terrible happens, but it will give users a chance to accidentally include this in their parameter declaration, in their variable declaration, and then you cannot change the implementation. So just like collectors do not expose their state, this will also not expose its state. Just there because then it makes it easier to put all the pieces together type safely. Okay, and this is the output type. So let's go from T to R because we're implementing map. And now this is pretty straightforward. First of all, we have to apply also the new type parameters here. And then what we do, well, we don't just push the element. Instead, we're going to apply the function, right? We're just going to call mapper.apply, apply the function to the element. And then up here, we can call it. And let's say we're going to take a letter and we're going to just, I don't know, put a colon in between and have that there twice. Now we run this, and you're going to expect A, B, 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 D, D, and so forth. Okay, I want to start doing something that is not something that exists already, but I'm going to start with something that is a limitation of what already exists. I'm going to implement a weird kind of looking flat map. So I'm doing a flat map, but this flat map, let's just call it, this is a weird flat map. This does not map from one element to a stream of other elements. It's going to map from one element to a list, or we can take a stream actually, but of the same element type. Right? So that's kind of what I think so that's kind of uncommon, right? Like why would it be that limited? But we'll see later what we can get from that. Okay, so what we do now is we take the element and the downstream, and now we will have to apply the map, right? So let's go there and let's take the mapper and wait, is it? Oh, wait, sorry, I think this is confusing to me and to the IDE. Okay, let's apply this to the element. And now we have a stream, right? And what do we do for each stream? For each stream element, we push it downstream. Now, there's one more thing that the integrator should do, and that is that it should, wait, why do we get a compiler error? Oh, right, yes, my bad. Absolutely my bad. This is no longer a list, right? We're going from T to T. Okay, and now we have a stream for each. I'll get it done. Oh, right, yeah, what's missing the return value? That's what I actually want to tell you about. So there's one more task that the integrator has to do, namely it has to signal, or it should signal back upstream, do we want more elements? This is not strictly speaking necessary for correctness, but it's very good practice. And I'm not doing it well here, because here I'm basically just saying, I'm going to push all the elements that is flat mapped to downstream, and then we're gonna push all of them downstream. The downstream will react correctly, even if it was like a find first. It will discard all the other stuff we're pushing there. We're basically just doing too much work. But it's not a big deal. But what we can also do is we can ask, are you rejecting? And then say, okay, if you're not rejecting, then we can push more elements downstream. Okay, so this one does not a whole lot yet. And, oh, that's not what I want to do. Stream.off. And then we're gonna go, we'll just duplicate it. We're just gonna have 2 letters. And that's that. One more parenthesis, and we got it. Okay, so again, why would you do this? Just do a kind of flat map. But I have an idea here. Maybe we don't do this always. Maybe we only do this under certain circumstances, right? I have this predicate here, is even. What if the idea behind this weird flat map is only if the predicate is true, will we flat map? Otherwise, we just let the elements float through, right? So we call this a flat map if. That is suddenly less weird. That also explains why we have to do the same kind of, why we have to keep the same type, because some elements we just want to pass through. And if we want to pass them through, that means a T stays a T, and so then the mapper cannot match to a stream of R. Okay, so let's have a predicate of T here. Sometimes I do type correctly, I promise, just never on stream. Okay, good, that's a test. And then we're basically doing this in a big if, right? We're just saying, well, if the test, so if the element passes the test, then we're going to do all of these things. And so there we go. And if we run this, we will now see a compiler. Let me try to figure this out. Where's the little red thingy? Down here somewhere. Oh, right. Yeah, we only return from within the if. That's not going to work, right? We need to return on all paths. That makes sense. Okay. There we go. So what we're seeing now is, and I forgot to pass the other element on. I forgot the else path, because else we want to put just the element downstream, right? The element push downstream. Push the element downstream. That way around. Okay, so now we see that, for example, the A persisted, and then the B was duplicated successfully because it is an even letter, whatever that means. And then D was also an even letter, and then C isn't, so it stays on its own. Okay, so that covers the basic part of a gatherer, which is the integrator. I said there's 4, so let me quickly go over the other 3. There's 2 more that you want to interact with when you build state. So let's say you want to do something like, I only want to pass on the element that is the largest element I've so far seen according to some comparator. So what I would then have to do is I have to memorize what was the largest element I have seen so far. So you need state. And I'm not going to get around to do a code example on this, but I want to explain to you how this works. There's 2 building blocks coming in for this. One of them is called the initializer, which initializes some state. And then the downstream will get the state here. Now it's void, so it can't do anything, but the integrator can interact, not the downstream, the integrator can interact with the state and ask it questions and change it and whatever. And then you might need, when the stream pipeline is all done, you might still do more things. You might still have to emit like the last element or something. So there's a finisher, which is the 3rd building block, which gets the state and the downstream at the very end, and then can push out more elements. And the 4th one comes in when you want to do states in parallel streams, which is when you need to combine the state of several partial interactions and then put them back together. So if you're interested in that, we have videos about stream gatherers on our Java YouTube channel. I think the newest one is Jose, who did like more than an hour long deep dive about the beginning of this year. It's very informative. So if you're looking into learning more about gatherers, you should definitely take a look at that. And now, we're done with that?
We are.
We are.
So now we are going to check again on the polls from the audience that we've been running. We're gaining valuable market insights with these. It's part of a social experiment.
Yeah, that is true. Let me see. This is the one, and then there's another one, right?
Yes, I think that's the one we just probably completed.
Yeah, there should be another one here.
Some of the chat was cut off.
Okay, we're just going to discuss the one then, and we'll see later.
Yes, we'll gather that valuable market research later.
Yeah, it must be somewhere lost in chat. Okay, so what features are you most looking forward to in Java 25 was the question. Which I think that one is one that is very... I mean, I don't mean it in any bad way. But
they're all great. They're all great,
no, but
right?
it's an emotional question. It's not like, what will provide most return of user value? Whatever. It's like, no, what do I enjoy using? So what do people say? Virtual threads and scope values, 55%.
I wonder how much of that is virtual threads versus scope value, because I mean, scope values seem really cool, but I don't see that many Java developers actively. Now, I'm interested in ahead of time computation because, well, you know, I might be doing a few things.
Because you're a dork, you're in the minority.
Yes. Well, I'm number 2. You know, come on there.
Yeah.
Stream gatherers, though, I think.
Oh, I didn't know we were making this a race.
We are.
My topic lost.
Your only topic lost.
Actually, I'm surprised by that, but I think it's really an indication of
the
what
losing.
People. Yes, that also, and coping now. But what people spend a lot of time with. So I like if you run stuff that actually runs at scale in production, then clearly observability out of time compilation, like for
well, you're going to spend less time running it, right? Because you're gaining time back.
Exactly. And also virtual threads for scalability. All of those are excellent for like when it runs in production.
Yeah.
But I don't do that. I'm a developer advocate.
Exactly.
I just write demos.
We just do proof of concept anymore.
Exactly, and stream gatherers are great. It's just a lot of fun. So I already wrote a bunch of them for like demos like this. There's also Project Gatherers for J, by the way. This is not the only one that gathers all the gatherers, so to speak.
Yes.
So yeah, there's that. And then last though, paving the on-ramp. That's a bit...
That's a bit surprising. I
dare say disappointing.
Yeah, I think that's going to be really interesting because I've been always... I actually even used some of it to do like some simple scripts for some of the videos that we've been doing to like quickly rework a bunch of file names and all that stuff. So,
but I'm going to flip it around though. I think one of the reasons why I think gatherers and on-ramp features, if you ask people about that, and I do a lot at conferences and at Java user groups and wherever else online where people meet me, nobody's like, no, those are boring features, I don't want those. It's just that the other ones are maybe more exciting. So
exactly.
Make it that, right?
The best of the best, right?
Exactly, yeah.
All right. Well, that said, though, we're going to be handing it over to Anna and Chad to talk about some AI stuff.
There we go.
Welcome back, folks. We are here happy to talk about Java and its impact on the AI libraries. Most importantly, I have with me today Chad Arimura, who's the Vice President of Java DevRel here at Oracle, or how we like to call him, our boss's boss. So welcome, Chad.
Thank you, Anna.
Well, we're not gonna waste a lot of time and just dive into the topic, because there are a lot of questions about what does Java do for AI? Is there anything about AI in this live stream? So we are starting the conversations here, and then we'll continue a little bit longer with Paul and some demos. So Chad, can you please tell me, where do you think Java shines today with respect to AI? Is it model? Is it inference? Is it training? Where do you think that's?
Yeah, thanks for having me. AI is everybody's favorite topic at the moment, and we've obviously been tracking it very closely and watching how the industry progresses. My joke recently has been, it seems like things are changing every 6 minutes, but we generally talk about this to the media and do live streams every 6 months. And so what are the sort of patterns that we're seeing emerge? Let's first talk about some of the use cases of AI. So number one, people are generating a lot of Java code with generative AI. They're using LLMs to say, give me a Java application, Java 25, Spring Boot, that has this interface and it does this and this and that. And that's producing a lot of Java code. And then number two, as everybody knows, there are millions of Java applications out there. I like to say half the world is powered by Java. And they either have their own internal mandates, or maybe the CEO is yelling at them saying, we need to be an AI company. And it's like, how do you make those Java applications take advantage of the great stuff that's coming from AI? And then number three, as you mentioned, there's model training, deployment, and let's say maybe fine-tuning your own models. So let's take each of those individually. Number one, Gen AI. Java is an excellent language to trust when your AI LLMs are producing code. The reason is, well, first of all, it's built on the battle-tested JVM. 30 years of just incredible piece of machinery that has been battle-tested, hardened over time. It's just an incredible piece of machinery that you're going to get software that runs on top of this thing. Number two, there's an incredible ecosystem out there of libraries, of dependencies, of things to turn to for testing, debugging, monitoring, maintenance, because generating the code is only one part of it. You have to actually turn this thing into something that you can use and scale over time, and Java is great for that. And also, it's a strongly typed language, so you're comfortable that you have a test infrastructure, that you know if it compiles, you know it's going to run, it's safe, unlike some other languages. And so those are the three use cases out there. Let's take integration into your own
I think that's a very common
apps.
use case.
So
nowadays.
You've got an application. It's like, let's say you do travel reservations or hotel reservations, and you want to use AI to take a hotel, go out there, get reviews, get information on the hotel, summarize it, and send an email to the user who maybe made a reservation. You can do that from your Java code with frameworks like LangChain for J, with Babel, which is quite a new one, with Spring AI. There's another one from JetBrains called Coog that got announced recently. So there's some really exciting things coming in the ecosystem. But those are also built on top of the incredible primitives that the Java platform team has built. Things like virtual threads are finding their way into these libraries. Project Panama for foreign function and memory API. Amber, obviously, for doing data-oriented programming. Because a lot of this is just shuttling data around, taking it off APIs, taking it from the LLMs, turning them into structured data. You can even get structured data back from the APIs, put it into your application. And so those projects are really great for that. And then finally, you mentioned training and fine-tuning. Of course, there are some specialized teams that have a lot of skill sets around machine learning and data science. And yeah, we have some work to do here, but we're very actively working on projects. Panama, Valhalla, Babylon. There is an implementation on top of Babylon and Panama called the Heterogeneous Accelerator Toolkit, or HAT.
That's supposed to be like a framework so that as regular developers be able to interact with the GPUs in a much more, let's say, familiar way, and not get a lot into the intrinsics. So thanks for bringing that up. We're going to talk about that one a little later with Paul, and he's going to show us a few things. He promised he's going to show us some code.
Yeah, it's pretty cool, so check that out. And so there's a lot of work going on in all these areas to make Java shine.
That's amazing. That's amazing. So given this context, what gaps do you think that all these libraries, libraries like LangChain4j, you mentioned Spring AI, and Babel, what gaps do they fill in at the moment?
Yeah, that's a great question. So In general, what we're finding is that the model shops, the frontier model shops who are doing incredible work, they tend to be on the machine learning and data science. I mean, that's their specialty. And so they have a natural tendency to gravitate towards Python, which has been a great language for machine learning and data scientists for a very long time. But then what you find is that sometimes Java doesn't get quite the attention that it should in those shops, and that's where the ecosystem has really stepped up. So personally from the Java team, we want to thank all of the projects out there, the folks working on LangChain for J, the folks working on the Spring team on Spring AI, Rod Johnson, who's been really promoting in Babel, the folks at JetBrains who do excellent work, obviously. I've been working on Coog, and they really step up, and their model is making it so that you can abstract out the APIs, the individual frontier model APIs, and in a very Java-centric way, be able to build and integrate these LLMs into your application, even local LLMs. So you want to take, let's say, Llama models or some open source model that we haven't even heard of yet, run it on your own enterprise hardware. Maybe you want to run it on Oracle's cloud GPUs, but you can do that from the security and safety of your own enterprise. And those frameworks make it possible to do that. So it's really cool to see. And they're being built on the top of the work that we do.
Yeah, what I find impressive is that the way that the JDK works has empowered another model also for contributing to the AI libraries. Take for example, I think that the engineers that work at Red Hat, they contribute quite a lot to OpenJDK. But some of you might, if you're looking, some names of those are also contributing to LangChain for J, and I'm following their contributions as well, to the downstream, what's going to happen, and what they're doing, to improve the ecosystem of AI in Java overall. So as you say, we are a very strong ecosystem that's interested in sharing and making everything even better. So it's pretty cool to see how Java empowers all these libraries out there. I think that we have time for one last question, because Shar has mentioned Java 1 2026 so many times. And now I am curious, because we're talking about AI, we're talking about AI libraries. So what can I expect from Java 1 2026 in terms of seeing about AI?
Well, first of all, we're not renaming the conference to Java AI 1. Well, actually not yet, but we're incredibly excited for Java 1 2026. As many of you know, and many of you came last year, we brought the event back to California here in the Redwood Shores campus at the conference center. We believe it was a really great conference. We got excellent feedback from everybody who was there. And so we're really thrilled to announce that we're bringing it back in 2026. So what can you expect? Last year we had an AI track with over 11 talks that focused just on Java and AI. This year, expect more and more AI talks at the conference, but not just slapping AI from the side in and saying, no, we're now an AI conference. Really, really good talks from folks that are working on the platform level stuff. So Project Valhalla, Project Babylon, Project Panama, the foreign function and memory API, the HAT, as you mentioned, the Heterogeneous Accelerator Toolkit. There'll be talks on that. There'll be talks on top of GPUs. But then even above that, where does this expose to the end user developers? Contributors to LangChain for J, folks from the Spring team, hopefully folks from Babel and JetBrains will be able to talk about the frameworks that they're building and what they're seeing in the market. So really applicable AI talks for people who come to the conference.
Actually, there's a little bit of time in between now and Java 1, so I'm expecting people getting their hands dirty with all the new features that are coming in Java 25, but also that are coming into the AI libraries. Experiment even more, draw some more insights from that. Maybe we see a new protocol, this year was the year of MCP. You never know what's the next year about. So we're looking into cutting edge topics to be presented to you, to show to you that you can use your Java skills even in the AI space, and you don't need to reskill yourself into other languages, and you can still use the language that you love and cherish and you spend so much effort in learning and becoming an expert at it. So Chad, it was a pleasure to talk to you. I'm very happy that you are here. Folks, if you have more questions, drop them in the chat. And please stay tuned. We're having some more extensive session about Java for AI. It will be live coding. It will be really, really cool. And yeah, well, now I would like to hand over to Billy for ahead of time computation in Java and to tell us more how that works. So more Java features in JDK 25 with Billy.
All right, happy to be back on the Java 25 launch live stream. All right, so I'm going to be talking about ahead of time computation in Java, or doing actually a live demo on it to help kind of level set for a future conversation we're going to be having here with Paul Bakker from Netflix, and also just to introduce it as well because this is going to be somewhat of a new feature for many people in Java 25. So ahead of time computation is coming out of Project Lightning, and the goal of Project Lightning is about improving startup, warm-up, and footprint for Java. But the key difference here from other options is that it's preserving Java's dynamism. So you're not going to have to make any sort of programmatic changes to take advantage of these features I'm about to show you. So far, there have been 3 features that have come out of Project Lightning: ahead of time class loading and linking, which came out in JDK 24, which is JEP 483, JEP 414, made it a little bit easier for creating that AOT cache. And then finally, JEP 515 is ahead of time method profiling, which is about improving the warm-up of the Java application. So let's take a look at what this would actually look like in practice. And let me end that. Perfect. So once again, I am running the Spring Boot Pet Clinic application, and if I start this up here, so usually starts up in about 2.5 seconds. Okay, yep, and once again, start about 2.5 seconds, so you know I'm not lying, and I've done this a number of times. And so then now, if I was to run this here and do a simple slow test using this command line tool called OHA, I will just do it for 5 seconds. At just a given endpoint. And I won't claim to say this is like the absolute best representation of a load test, but it's easy enough to show here for like a simple demo like this. So we can see here that we completed about 75 or 770 responses. Okay, I'm going to go ahead and then stop this application. And now the first thing, so to use these features this ahead of time, the way it works is that you have to do things ahead of time. So the computation of startup and warm-up still has to take place, and this is going to be now kind of done during build time, and this is going to be done through training runs. So if I was to run this again, nope, that's not what you want to see. There we go. All right, so if I was to run this again, now I am going to be creating the cache. So I'm going to start it up, and it's going to run more or less normally here. And so it takes still about the same amount of time. If I run the load test again, it's going to run just about the exact same way as it did before. Perfect. So I will go ahead and now kill this application again, and we're going to see this is now creating the AOT cache. So the JVM was kind of monitoring all this stuff as it would normally do, but instead of just throwing it all away when I shut it down, it's actually going to take all that saved information and put into a cache. So remember from earlier, we started the application up in about 2.5 seconds, and we ran about 7,800 transactions. So let's start it up again. This time we are going to, we are going to use it with the AOT cache. So if I just change this command line to this argument to use AOT cache, it will start up again. And now it started up in about 1.66 seconds. So we went down from about 2.5 seconds to 1.6 seconds. So that's about 1/3 of a reduction in startup time. And now if we run this load test again, quote unquote, we are probably going to process about 8,500 transactions, or 8,500 transactions. Now, this isn't going to be a consistent throughput improvement. This is improving the warm-up, and that is because we saved those method profiles. So now, instead of the JVM having to wait to see which sort of methods, what sort of hot methods are being used, it knows that immediately. It can immediately start recompiling that code using the JIT. All right, so that is just basically a brief and quick and dirty demo demonstrating Project Lightning, the ahead of time computation. And stick around for us. We're going to take a quick 1-minute break, and I'm going to be having a conversation with Paul Bakker. We're going to be talking about how Netflix is using the new features post-Java 21 at scale, including AOT and some other concepts. So stick with us. We'll be right back. All right, so that was a very quick break. So we're back here with Paul Bakker from Netflix. Maybe a few of you have heard of it. Maybe a few of you probably use the service. So just before, I was talking about ahead of time computation. So I was wondering how you guys have been maybe experimenting with ahead of time computation at Netflix.
Yeah, this is a super interesting feature for us because startup time, probably for everything, but also for us, is really important. We deploy a lot, like many times per day, and that means every time we do a new deployment, it takes a while before a set of instances in a cluster is started up, and basically every second we can save there gets that new version out more quickly. And it is also really important when doing auto scaling, when load is increased. We need to scale up these instances as quickly as we can, and again, every second counts. Yeah. Now with AOT on the way, that is something that is just really going to help there, and it's going to shave off a lot of time, basically. We have been looking at AOT since the first preview that came out, and it has been getting better every time, basically. And we are not quite completely in production with it yet. We have been testing in production. But the plan is now with 25, it is like complete enough that we're actually planning to go fully in production with this.
Fantastic.
So over the next few months, we're basically going to roll this out, and eventually every service will basically leverage this.
So I've been starting to do some presentations on AOT here over the past summer. And one of the things that people, I think, get a little bit tripped up on is, so one of the things I demonstrated was doing a training run. And how are you guys actually kind of doing training runs at Netflix? Like, how are you guys incorporating that into your build pipelines?
Right, so
deployments.
The luxury that we have is that for our most important services, we always run canaries before we actually push something to production. And a canary is effectively a real production deployment, but we only send like a small percentage of traffic to it. Now a small percentage of traffic still means potentially millions of requests. It might
still be quite a bit,
and that is perfect for a training run, right? Because it is real traffic, it's the real thing, and that means the training data that we get out of that is pretty much perfect. So what we're building right now is during a canary, we will basically pick one instance, because a canary also runs on many instances typically. We pick one instance, and that one instance is going to be responsible for collecting the training data. Now, one thing that we noticed that is really important is that there's almost no overhead in enabling the collection of training data, because otherwise we couldn't just do this on a canary, because it would actually impact our numbers. So we can safely do this, and that means we get a real training run basically on very real requests, and then when the canary is complete and we're happy with it and we're pushing it to production, and again, this happens multiple times per day for most services, we can use that training data, and the whole cluster that is then going to start up in production is going to leverage that training data, and we're just getting all the wins there.
So I guess two quick things there. So one really important thing when you're doing training data is to simulate production as close as possible. So that's actually one of the things I was kind of speculating on. It was just like canary deployments would be a really good example of that. But of course, if you can't do that, maybe you just take some sort of save data set and run it against that. So the other one then is, what are you doing with the AOT cache? Like, how are you also actually where's that living?
So when we collect that training data from a canary, we're basically just going to upload it on S3. So most of our stuff was on Amazon. We're just going to upload it to S3, and then from there it's going to be distributed on all the instances that we start for the actual production deployment.
So is that a shared volume then, or is that going to be actually in the actual container image, I guess?
We are still kind of experimenting with that, but most likely it's going to be as simple as literally just putting it in an S3 bucket and downloading it from there, because that is quick enough. It's not that much data either, in the grand scheme of things. So that seems to be just good enough. Very simple.
That makes, because that's also one of the things I've been talking about. It's okay, because I think a lot of times when it's been discussed, it's you're going to include a container image, and that is entirely valid. But I was also thinking well, if you do a canary deploy like what you guys are doing, well, just take that and put it into some shared location, and then as the other instances start up, they can instantly read it, and you don't have to go through the process of we did a canary deploy, but then what we're really deploying is going to be a little bit different. It'll actually be all the same. Really
That's
interesting.
super important because we want to keep those images immutable.
Yes.
So we don't want to mess with it after we did a canary, basically.
Exactly.
So, that's exactly the reason.
Perfect. All right, so that's really interesting. Another newish feature you guys have also been kind of working with is ZDC. So yeah, ZDC is one of our newest garbage collectors. One of the big things about it has extremely low pause time, but yeah, you guys have done some experimenting with it, right?
Yeah, absolutely. So this was actually a big surprise to us, like a positive big surprise. So when 21 came out, ZGC was first enabled there, and it wasn't generational out of the box yet, but there was a feature flag that we could turn on to make it generational, which basically makes it the same as we now get with 25. So we have actually done this since 21. And our expectation was that, okay, ZGC might be interesting for very specific workloads. That was the expectation. Because we had seen that previously with Shenandoah, and for most workloads it doesn't quite work out, but for some specific ones it does. However, we turned it on, and what we saw was really surprising. It was just better. Like on every aspect, basically, it was just better. And very quickly we decided, like, well, this is just a better default even than G1 is, and we had been running with G1 for a very long time. Lots of tuning that went into that, and without any tuning, we could just enable ZGC basically, and it was better than what we had. And to quantify better a little bit is, if maybe you can pull up this one slide. So what we see here is a graph that we got from our observability. And this is on one of our biggest services. And the graph that we have here is the pause times that we were seeing with a garbage collector. And where the red box is drawn here is when we turn on ZGC. And you see that it has pause times for a while, and then it just drops, and there's nothing. There's literally nothing there in the graph anymore. It doesn't mean that the data collection stopped. It kind of looks like that. But that was actually the data collection on ZGC. So pause times are just gone, and that makes sense because that's the whole idea of like a low pause garbage collector. But it's still super impressive to see. Now, you would maybe think that, okay, this comes at a trade-off, right? Because nothing is for free, so where do we pay for this? And in theory, you would maybe spend a little bit more CPU time constantly on it. However, what we have found there is that kind of goes away because we are saving CPU because of a different reason. And for that, I have a second graph here. These are the error rates that we see in services. And the white graph here that keeps going is on G1, and the purple is on ZGC. And again, you see that when we turn on ZGC, the error rate just dropped. Now you might be wondering, okay, why are your services have less errors basically just because of a garbage collector? But if you think about it, that actually makes sense because a lot of our services are being called by other services, and there's a whole chain of services calling other services. If in one of those services there's a small pause, that service just doesn't do anything at that point. And even if that's a fraction of a second, we need such aggressive timeouts on our remote calls, our IPC calls. So let's say you have a gRPC service talking to another gRPC service.
And IPC is inter-process communication?
Exactly.
Okay,
So it can be gRPC or HTTP, it doesn't really matter. One service is calling another service. Is that other service is in that pause window and it's sitting there for like maybe half a second, we're failing all the requests because we can't wait that long. And now we have all this extra traffic because we do a retry and some other service is going to get the traffic. So we're saving all that work basically, and because of that, the net effect is that we're actually running at lower CPU, even though the garbage collector technically is a little bit more expensive.
That's really interesting. So and it's also kind of one of those satisfying things, just like, because now, as Nicolai and I were joking just a moment ago, like we're DevRels, we're not actively like really doing like supporting applications, so it's like kind of going back on my experience of like how this would work, and it's just like, oh yeah, ZDC would work really great for microservices architectures, and it's one of those things like it's difficult to communicate just to comparison and pause times because G1 GC, like a lot of times its pause times can be like a couple of milliseconds, which isn't bad, but when you're at your guys' scale, like even a couple of milliseconds that can cascade to where it's like one service happens to hit the pause time and then another one hits the pause time, like all of a sudden you get a bunch of failures. But like ZDC, it's microseconds. It's like 50 microseconds consistently, and then that it doesn't hit your pause time.
Exactly, and it just makes it more predictable. So, running these services just becomes like easier to reason about. And we don't have to keep into account like, oh, but what if this pause time thing happens, and now we need to keep capacity basically for that error scenario. That whole reasoning is kind of just not necessary anymore. So that's really great. Yeah,
that's really interesting. I didn't think about that because that is one of the trade-offs. So the way ZGC works is that it does everything concurrently. And when it's doing anything concurrently, well, those concurrent processes is taking CPU resources that could be used by the application. But when you actually operationalize it, in at least your guys' case, it actually ends up saving you CPU time or overall resources because now you're not having to handle error rates. That's really great to hear. I'm sure some of the ZGC team, if they see this, would be really excited by that. All right, so we are going to talk about one other really interesting topic. Virtual threads. We've talked about it a few times already. So we introduced virtual threads in JDK 21 as we kind of covered earlier, but there was an issue with that. I don't know if you guys, if you want to kind of speak to that issue.
Yeah, absolutely. So virtual threads has been like the feature that I've been waiting on for a long time now because it's been in the works for quite a while, and I've been saying from like many years now, like this is going to change how we write Java code. Like fundamentally. And so when 21 came out, myself and many others at Netflix were very excited about it. Like, okay, finally it's there. We can start using this. And there's kind of two different ways we see how you can use this. One is you can put it in your frameworks, and that is kind of how we started. So my team is responsible for like the framework we built on top of Spring Boot. And we started putting virtual threads in there basically as kind of the default executor of both how the web requests are being handled, but also like if you start other jobs, those would by default run on the virtual thread. And in the second place is our GraphQL framework, the DGS framework. Like the data fetchers are all going to run on virtual threads out of the box. And the nice thing about that approach is that as a user, as a developer, you don't have to like think about virtual threads. It's just there, and it's just your service is just potentially just going to run faster depending on what else is doing, but it's not worse.
Yes.
Like that's the nice thing about virtual threads. You can put it in a framework at no cost, and if you have a lot of blocking I/O, you're probably going to run faster because you can do more stuff at the same time without consuming too many threads. But if you are actually just CPU bound, it's not going to be worse. So that's like the one scenario. The second scenario is, okay, can we actually put it in user code? Can I, as a developer writing my service, do things better, easier, etc., based on virtual threads? Now, for that, I think we also need to talk about structured concurrency because I think that is actually going to unlock that. So we started with a framework approach. And we just turn it on our biggest services. We like to experiment on our biggest stuff because that's where you get interesting data. We turned it on, and it was working really well for like a while until it didn't. And then we were like, okay, this whole cluster basically just deadlocked. Like it was just not doing anything, literally not doing anything anymore. And we're like, oh, what is going on? And some of my coworkers actually wrote a really interesting blog post about this, and you should definitely take a look at that. And what we found is that depending on kind of the libraries you use, if there's an interesting combination between reentrant locks and synchronized, and synchronized in JDK 21 had the potential of being pinned to a thread, a platform thread, you could get into a deadlock situation where none of the virtual threads would be able to do work because there were no platform threads available, but all the platform threads were taken by virtual threads because they were pinned on it. So nothing would happen anymore. So because of the thread pinning issue, it is, by the way, very rare. I still have many services running at slightly lower scale that are successfully working with virtual threads. But then if you really push it in like large scale, you eventually will get into this problem. So we kind of backed away a little bit from pushing everything towards virtual threads, knowing that it's going to be like a fixed problem. Now that it is fixed, it's fixed in 21, in 24. But now that it is fixed with 25 there, we are going to make another big push to actually get us to our services. And we expect quite a big difference.
Yeah, and I imagine. And so like particularly, again, kind of in how you guys work of a microservices architecture where, you know, we have one call, like someone comes in, is like, I want to see some movies, and then sends up a bunch of calls. But as it's doing those other calls, while that service that is making those other calls is waiting, you know, it's just sitting there doing absolutely nothing. And this is where virtual threads comes in. It's just like, okay, well, that's sitting there and doing nothing. That virtual thread will be parked, and then that opens up that platform thread to continue to do work. And that, I can imagine that's going to make a huge difference, or has made a huge difference already, and then it's going to be even better now that it's unpinned.
Yeah, absolutely.
Yeah. So you mentioned how it's affected some of your framework code. So like how have you guys maybe updated your framework code internally?
Yeah, so there's a few things. The very easy one, but also maybe the most important one, is with Spring Boot, you can literally just turn on virtual threads.
Yes.
And then from that point on, like the embedded Tomcat that we run on, will use virtual threads for every connection that comes in. So we still use the model of basically having a thread per request. That is now a virtual thread per request. And that just makes it easier to scale, because those can potentially be many threads, and all the real threads, the not virtual threads, take memory, and there's only so many you can have. So that's one, and you don't have to change anything in your code to use that. It will potentially just run faster.
Yeah.
Then we have, in most services, we have like a thread pool traditionally, where other work is happening. Like you start some background jobs, maybe you do a fan out that needs to come back. All these things are going to, by default, now run on virtual threads. In our GraphQL framework, every data fetcher, typically in every request for every query, you will have many of those, like maybe 50 to 100 in like bigger queries. Each of those will now run in a virtual thread. And again, just the potential to do more parallel work, if it's possible, while not having any cost of doing this out of the box. And previously we couldn't do that kind of behavior.
So one of the things, so before you were talking about how to use thread pools, and like you used thread pools before because it was pretty expensive, like it's about like a meg or so, I think, of heap space per thread, and then spinning one up and tearing one down, there could be some costs around that. So it was a finite resource, so you would pool them instead of, you know, constantly creating new ones. That's taken away now, virtual threads. So a question also when I've talked on virtual threads is like, oh, okay, now what do you do? Like, have you experienced, like, now that threads are no longer a bottleneck, have you experienced like your next bottleneck, and like how have you maybe handled that? Because
you're eventually going to just run into the next thing, and then like until we solve the next thing, maybe we don't really like get more performance out of it. It unlocks the doors.
Yeah.
So right now, a lot of work goes into often tuning these thread pools and tuning how many outgoing connections, for example, we can have to like the next service that we need to call. That tuning process is very manual and really hard to get right. Like, do we need 50 connections or 100 connections? Like, who knows? The only way you can figure it out is by trying it in like a canary, and then the load changes and you have to do it all over again. Or you move to a different machine on AWS, and again, you have to do it all over again. A lot of that work won't be necessary anymore. So it will take some time before we like put this in place everywhere, so that we can just kind of stop thinking about this. But the fact that we in the future don't have to think about every thread pool and how to tune that anymore, that will be like super nice to have.
Yeah, I'm just curious, like one thing like we talk about, like that if now all of a sudden you can like launch a bunch of requests now that you're no longer thread limited, like do you guys use semaphore blocks at all, or is it using other ways of limiting it, or is that just not?
Yeah, no, that's another interesting topic. So this is also maybe getting a little bit more towards user code. So if I as a developer want to do a fan out, and I have to do like 5 calls to 5 different services, and then it has to come back, and I have to combine the results of those 5 calls. Like very common use case, almost every request will go through some sort of process like that. Without virtual threads and without structured concurrency, there isn't really a nice way to do this in Java, except going into the realm of reactive programming. So we still have a lot of reactive code for exactly that use case. We do a fan out, and we need some sort of API to reason about that fan out and bring everything back together. Reactive programming is kind of the best option we have there right now, or the only option, I should say. It's not an option that anyone is happy with at that place, because it is And it's very complex to reason about. If you look at like a fair block of like reactive code, like I can't figure it out. Basically.
Same, like I struggle with it as well.
And I've been doing this for many years now, and still I'm like, oh wow, this is kind of hard. It's also just harder to debug when you look at stack traces and things like that. So while Netflix like pushed a lot of the reactive programming paradigms like many years ago, like RX Java came out of Netflix. We have kind of learned our lesson the hard way, and it's just really hard to do at scale. So we can replace that with structured concurrency soon and virtual threads, and it will just make it so much easier to look at that code. And we're just back to just doing plain Java programming, and I'm very happy about it.
Yeah, I'm never happy to hear about other people struggling, but at least when people struggle about things with I struggle with, it's like, okay, it's not me, it's legitimately difficult. That said, structured concurrency, we touched on it a couple of times. Yeah, if you want to maybe touch a little bit on it, because I'm really excited about it. I was really hoping it was going to make it to Java 25, but I knew it wasn't because like we're pushing a new API. But yeah, go ahead and maybe touch a little bit on structured concurrency and maybe how you guys touched on it or experiment with it maybe.
Yeah, we've been, so typically when an interesting preview feature comes out, some teams will immediately start experimenting with it. So for structured concurrency, we have been like playing with this for quite a while now. And it is such a nice, simple, small API. And again, it's just so much easier to look at than reactive programming is. And I can't wait until we can like put it everywhere. And while we always have to be a little bit careful with preview features, obviously this is like, what is it, the 5th preview or something?
I believe it is the 5th preview, or it's going to be going to the,
So I'm fairly confident that it's not going to fundamentally change all that much. So we're maybe not going to put it everywhere, but we can put it in like many services where we can just deal with the changes if necessary. So I think we will start using this with 25, and then I can't wait until this is like fully landed in 26 or the future.
But like what's really nice about structured concurrency, because like writing concurrent code in Java is difficult, like, whether writing reactively or even imperatively with like executors. But like you're talking about your fan app scenario where you have one call and you make a call to like 5 other services or something. And like how you handle that, it's like, okay, if one fails, does that mean everything fails? Does it all have to succeed? Like that's going to vary. And structured concurrency allows you to reason about those subtasks. And there's also like the structured and unstructured concurrency. It's just because now there's a relationship between that parent task and that subtask. And like that's going to be huge when that's all done. And so yeah, that's going to be super, super nice. So I think one last topic. So you're also mentioning how you guys are already you experimented with AOT, you're experimenting with structured concurrency, and so like a lot of these are already preview features. So how does like Netflix kind of like keep up with like these new features and stuff like that?
It depends a little bit on like what team we're talking about and what the service they're working on and what kind of life cycle that is. So for often our most important services, they're like deployed many times per day. There's teams working on those every single day. For those, we typically push to new versions sooner. And it's a surprise to someone, like, okay, are the most important services are going to be behind? No, we're actually going to like upgrade those first. Because one, we want those performance improvements that we get with every JDK. And two, the developers want the language features that we get. If you're not really touching your code all that much, maybe you care a little bit less about the language features, but you still care about the performance. So we do kind of a staggered release. So in the next couple of weeks, we will have 25 available for like general use at Netflix. And then first it will be up to the teams who want it to enable it. Basically, it's a single like number in a Gradle file basically that they have to flip, and it will just work. And the teams that really want the language features, they will start using it right away. And this will happen very soon. And then when it comes to performance, even the services that are maybe not as active in development, we are going to like update those services as well. And we have done that so far. Like the baseline is today is 17. Most of our services, or many of our services, are on 21 already, because again we have CGC. And we're going to push those to 25 like over the next few months. So yeah, we're pretty aggressive with picking up these new versions.
Fantastic. And I think a few seconds, but also your most deployed services are the ones you're updating first, and that's because you have the DevOps maturity around them that allows that. And that's really some of the benefit. It's you get so mature in your DevOps and operational, you can upgrade faster. And that's ultimately the real benefit. You're not doing it to upgrade to the most recent JDK, you're doing it to have a stable release cycle. So anyways, unfortunately we're out of time. Thank you very much, Paul, for coming out here and talking about how Netflix is using more recent Java features. And I'm going to hand it over to Nicolai and Anna. They're going to be talking about more of our poll results.
Yeah, thank you, Billy. Right, so we had 2 more polls running, the last 2 we had, and the first one we're going to talk about is which one, Anna?
The first one I want to talk about is what keeps you coming back to Java after all these years. I think that you landed in our live stream because you like Java, I hope so. And well, we were interested to know what makes you still trust Java and develop with Java. And we got some interesting results, was very tight. I didn't respect so many. Let
me briefly recap them for those of you in case you can't see it in the chat. So we asked about stability, security, and reliability, which was first place with 33%. Huge ecosystem with vibrant community, 28%. Continuous evolution, 25%. And tooling and JVM performance, 13%. Yeah, as you said, that's very close, right? It's the spread from just 20% from lowest to highest for 4 questions. I think that's pretty narrow. So yeah, I think what I find interesting here is that stability, security, and reliability made it to first place.
What surprises you there? People want something they can rely on, that's not going to break and be breakable on the first security attack that happens over there.
Yeah, I think compatibility is also part of that, right?
Yeah,
that the investment that you make into learning, but also the investment that that the organization makes into producing code, that all of that is maintained and not thrown out for reasons. There can be good reasons for that, don't get me wrong, but it's good as it happens as little as possible. And clearly, I think the Java developers, Java community as a whole.
Yeah, and the ecosystem matters a lot as well. And the fact that Java continuously evolves is not just stagnating and, well, that's a release and that you have to wait for more time for another release and new features coming up there. So the 6 months release cadence has helped a lot probably in seeing a much more accelerated evolution of Java as a platform. And, well, last but not least important, the tooling and the JVM performance, which they do matter.
So it's really kind of funny though. We're basically playing into the stereotype, right? Stability first, performance last. That's us Java people. But I think the reason though there is that which is something that people that joke about Java performance often don't get is the performance is just really good if you need it to be, and also in many other cases it's just good enough, right? For most projects it does not make sense. We just talked about Paul from Netflix. That is amazing what they're doing, but I think we can all agree that is not the norm, right? And for most people, so if you need that level of performance, you can get it. And if you don't, it's pretty straightforward to just use Java and get really good performance without going to all that trouble.
Yep, and of course we have asked our last question in the poll was that what area of Java 25 do you expect to impact your daily coding the most? And I was very interested in this one. And apparently the concurrency has most of the impact. And a lot of folks in the chat, a lot of folks have said that, well, concurrency will be the one that is impacting you the most. And we heard earlier that concurrency, the virtual threads and scope values, those are the first that impact things at Netflix as well. Then flexible constructor bodies, very tight to stream gatherers.
Yeah, they're tight. But so it's interesting. I think this question is to me personally, this question is a contrast to the other one. We asked what features are you looking forward to the most, right? That's what I described to Billy as more like an emotional question. What do you think is the most fun? This one is more but what has the most real life impact? And again, I am surprised, I have to say. I think, so my experience when I still did work in production, was that not actually that much of the code that I wrote was interacting with concurrency a whole lot.
So I'm not going to comment about the production thing.
She's so mean behind the scenes, but she's just too nice to read here. Okay, that was the polls, right?
Yeah, that was pretty much the polls. Thank you very much for
responding. Before we cut off the polls, because there was the last one we had, but we still want to hear from you, and we still ideally want to hear from you in person. So as we mentioned early on, Java 1 2026 is happening mid-March 2026, not surprisingly. Also when JDK 26 come out, so it's really, really easy to memorize. So we hope to see you here in the Bay Area, right? If you have the chance.
Yes.
Okay. And now we're going to do the whole thing. Nicolai hands it over to Nicolai trick again. So Nicolai is going to be there in a couple minutes to talk about more API updates for you. Not a couple minutes, not even a minute.
How modest of you. Self-praising yourself.
I didn't praise, I just announced.
Yeah,
See you then.
Yeah, see you. See you.
Yeah, and we're back. So, new and updated APIs. We already talked about the important ones, right? We talked about scope values, we talked about stream gatherers, we touched on structure and currency, but because it's a preview API, we're not going to go into that much detail. But there, as usual, is so much more going on that revolves around the topic of APIs. And one that technically is a tool, but you still use that for your APIs, hopefully, is Javadoc. So I think writing Javadoc is very important, and writing simple enough Javadoc is also a great experience. But once you start getting into more involved situations where you need like paragraphs and code snippets or lists or maybe even tables, it's not that elegant anymore, right? For example, I can never remember where to put the p tags in my pseudo HTML, which is what I blame, by the way, for these usability challenges. It is like HTML, 25, 30 years ago was kind of a modern-ish thing that people would maybe write by hand, but nowadays we just got better tools. So in comparison to that, I want to point out Markdown, which does not need you to have any paragraph tags, right? You just leave a blank line. Code snippets and code blocks are super simple. Lists are super simple. Tables are still terrible, but arguably less so. And if all of that fails, like if the Markdown doesn't do something that you want to do, you can just straightforwardly embed HTML and it just works. And that means that Markdown is basically just better HTML because you can do things that you can do things simpler, and where it doesn't do your trick, you just revert to HTML. And so I think that is the reason why it's so widely used, and that means so most developers really know it very well, right? We use it in issue trackers, in wikis, in our documentations, in READMEs, and now also in Javadoc. So you can use Markdown in Javadoc. And that you do that, it's very simple. You just start each comment line with 3 slashes instead of having the block with the slash and 2 asterisks. You will be using comment mark 0.30, which is the standard, and it implements almost all of that standard. One thing that is a little bit maybe uncommon or not uncommon, but something that you might find a little bit surprising is how links to other elements in the documentation work. Because not many people use this square bracket link syntax, where you put the text in square brackets, but then also the thing you want to link to is you also put that in square brackets, and then elsewhere you have to define where that links. And that is done for you. I'm going to show you that in a second. Also, Javadoc tags work as usual. So this just means it just becomes simpler. So I want to go through a few examples. Inline code with backticks, as you're used to this. You can have fenced code blocks with the 3 backticks in their own paragraph. Then if you do that, you can add a language there, right? Like Java or Shell or whatever. And this will end up as a CSS class in the generated Javadoc. So you would still need something like client-side code highlighting to make that actually be highlighted, right? So that's not something that Javadoc will do for you. As I said about the links, so if you write something like the module Java base and you put Java base into these square brackets, then this will be a link, right? This is the output down here. You cannot see that this is a link, but if I park my mouse, you can actually see it gets underlined. So that kind of makes sense, right? So it will link Java base to the module description of Java base, and it will also link that text, right? So you have the text there, and it links to the element of the same name. And you can do that with packages, modules, classes, fields even, methods, and all of that. You can also change the text. If you want to, you put first in square brackets the text that you want to link, and then again in square brackets, the thing you want to link to. Java base, for example, with a slash is the module, and then it will be linked to the module. So that way you can link to all kinds of things very easily. Markdown tables, as I said, less terrible, but still not great. Also importantly, you cannot do all things in Markdown tables that you can do with HTML tables, so you can still revert to HTML tables if you have to. In general, and as they say on the internet, no, this is not sponsored, but something like tablesgenerator.com or some other page that will allow you to generate tables is something I would highly recommend. Nowadays, maybe an AI tool can help you, but just typing out tables manually in either Markdown or HTML is terrible. But you don't have to do that. So if you do have tables there, I recommend to use some third-party tool to generate it for you and then copy-paste it over. As I mentioned, Javadoc tags, like here I'm using JLS or input spec, they work as before. And if they are in a Markdown block comment, meaning like after the three slashes, that means they themselves will also be interpreted as Markdown. So you see there, the input spec comment is this implementation does in underscores nothing. And that then means that the nothing is emphasized, so it's probably going to be italics. Okay. This is just a comparison of what this could look like. The details don't matter. On the left-hand side, you have the HTML. On the right-hand side, you have the Markdown. And you will see that there's a lot of stuff on the right-hand side that just isn't there. On the right-hand side, there's mostly just text, but the left-hand side has more craft, more HTML around it. So it just makes things a bunch cleaner. And I think that gives you the motivation you needed to write more Javadoc. Because, if you don't write Javadoc, God drowns a kitten. So there you go. There's a lot more going on. I don't want to go into this in too much detail, but if you use any of these classes, like if you use console, if you use reader, math or strict math, and you're into the exact overloads that are there, then you should definitely check out these new methods. Instant got a cool new overload of until. You can now say instant until another instance, and you get back a duration. Fork join pool added a bunch of schedule methods that make it really easy to schedule a future task. And body handlers and body subscribers, which you might have seen me earlier in the live demo, those classes are needed to process the result of a HTTP call, and they now have a decorator, which is called limiting, which means you can very easily define that this is the answer limit you expect, and then you get an exception if it's longer, which is good because that can help you, for example, in guarding against denial of service attacks. Also, something I mentioned earlier is weird spaces. So locale data, as I mentioned, is provided by CLDR, and some date, time, or unit formats now need narrow non-breaking spaces, which will never be inputted by users. So you need to have a way to parse those without them being present, right? So you need to be able to parse, let's say, a date time that is supposed to use narrow spaces when it doesn't. And the way to do this is lenient parsing, which is something that CLDR themselves, the Unicode standard themselves, actually propose. And you can turn that on in the java.time package. You can turn it on by getting to a date-time formatter builder and then calling parse lenient on it. And that will then mean that all white spaces are treated interchangeably. In the Java text package, this is actually the default. There you would have to turn off by setting set lenient false. So if you do update from 21 to 25 and you stumble over those changes that happened mostly in 20, but also some of them happened in 22, then this API will save you. And if you're on the way from 17 maybe even to 21, because JDK 20 brought a bunch of these changes, if you skip ahead to 25, some of those problems might be easily fixable for you. Okay, I want to briefly go over some bytecode stuff so that we can then introduce the class file API. What's bytecode about? Bytecode is the instruction set for the JVM, which is used to instruct it what to actually do. And the basic lifecycle is simple. You generate it with Java-C, you store it in the class file, the class loads, parses, and verifies it, and then the JVM eventually executes it. In real life, all of this gets much more complicated. Frameworks will interact with it at build time. Something like DigCompiler or native image will interact with the AOT cache, will try to prefetch it. JDEPs, Spotbugs, and other tools might analyze it. And it might also be manipulated by agents and libraries at runtime. So bytecode is not just this simple, well, the compiler generates it and the runtime runs it. There's a lot going on there. And most of those tools don't do it themselves. They go through what's called the library like ASM, and even if you use ByteBuddy or CGLib, they will also use ASM under the hood. And this creates a little bit of a conundrum. So that means if you generate Java bytecode with Java-C, then Java-C will embed what level of bytecode is being used. So for Java 29, that's level 65. And then all tools will look at that and say, okay, can I already work with bytecode level 65? And the new version of ASM can, and the newer versions can, of course, too. But then let's say we now update to Java 25. Now you're using bytecode level 69. And then ASM might not actually know it, right? So this is supposed to look like bytecode here. So this is my bytecode level 69, which came from the update to Java 25, right? Java 25 now generates, if you use it not just as a runtime, but also for compilation, bytecode level 69. ASM, in the original version, did just only do 65, but so it bogs. So what you need to do is you update that as well. But ASM is often shaded, or there are other reasons why you might then have to update other parts of the dependency tree. And suddenly, you just want to update to Java 25, you have to update everything. So this is the reason why we sometimes say, before updating the JDK, you need to update all dependencies. And we want to move past that. And a big chunk in moving past that is the class file API. It's an API that allows, it's in Java, that allows analyzing and manipulating bytecode. This is what it looks like. Details are not that important. If you've not manipulated bytecode before, you're probably not going to start now. Although it's kind of like an interesting API to look at, and there are some interesting things you can do. But generally speaking, you're probably not going to interact with it, but you're still going to benefit from it. Because with a stable API in the JDK that is always up to date, when you update the JDK, then any bytecode manipulation tooling might read new bytecodes, but most cases it doesn't matter. If you have like a dependency analysis tool running, for example, then bytecode changes, many bytecode changes will not impact you. And so that means if your bytecode analyzer uses the class file API and the class file API is updated together with the JDK, it will just keep working without having to update the tool. So ideally, we end up in a situation like this, where now that Java uses generates bytecode level 69, only the class file API is supposed to read it, and it does it out of the box. And then you do not necessarily have to update everything else. This is not guaranteed because perfect forward compatibility is impossible, but there's a good chance that this will heavily reduce the amount of, I have to update all of this now as well, just because I wanted to use like a new API or a new language feature. Okay, the foreign function memory API, we're going to cover that in just a minute, so I'm not going to go into any detail here. Just as a high-level overview, byte buffer and unsafe allow you to manage your memory yourself. Both of those have individual disadvantages that for the foreign memory API improves upon. And JNI is the Java native interface, your way to interact with native code, which the foreign function API improves upon. And both of those want to have performance that is comparable to those other solutions, but be much more safe and reliable, and also, importantly, supported in the long run, unlike, for example, unsafe. Unsafe is being phased out because it is, as the name says, unsafe. Byte buffer sticks around. I don't expect a whole lot of usage for that, but it's still a legal API, and also JNI is not going anywhere. Finally, brief talk about preview APIs. 3 APIs are in preview in the JDK 25 right now. Poonam already mentioned pen encoding and decoding briefly. Structural concurrency already came up a bunch of times. Just like one single slide on stable values. Stable values allow lazy initialization of variables, which is kind of easy. We don't need a JDK API for that. But then also, once that variable is lazily initiated, it is now final, like super final. The joke about more final than final is that a final variable can actually be changed at runtime through reflection, and that means the just-in-time compiler cannot rely on this never changing. And if it is changing, and there's a bunch of, or potentially changing, there's a bunch of optimizations it cannot do. So the first step, if I'm not mistaken, were records. The fields that back record components are truly final or final or whatever. And that means that they can actually not be changed at runtime. And so then those can be more heavily optimized. Stable values now rely on the same thing. Once the value has been initialized, it will be super final. So that's pretty good. And then also as a sneak peek into the future, I think just the other day a JEP was submitted and is now out of draft that wants to make a final really final, I think, through a command line flag. Okay, so that covers the preview APIs. That is all that I have to say about the APIs. And now we're going to go to Paul Sandoz and Ana-Maria to talk a little bit more about all the cool things you can do with Java and AI. Take it away, guys.
Thank you, Nicolai. Well, probably one of the most weighted sessions of today, Java for AI. I actually invited Paul today to show us a few things hands-on besides discussing what Java can offer for AI. What he doesn't know is that I'm going to stress over his shoulder while he's coding. Paul, before diving into the code, let's set a bit the stage for our listeners. What does Java offer today what does JDK 25? I'm getting JDK 25. Now, what I can use from it to do something with AI?
Right, there's I think 2 features offered by Project Panama today. one is that Nicolai already mentioned was foreign function and memory API. So it allows you to more easily reach out to all those native libraries that do machine learning computations. And we will show that today. And the other one is the vector API if you want to actually code computations in Java efficiently, leveraging all of the CPU silicon. You can use that to encode some of your sort of hot loops that do this machine learning computation. Those two primary things there. But I would say beyond that, there's the push of all the features in Java allows you to be more productive and allow you to have more performant programs. And that in general just reaches many areas, not just the core of AI, but also the aspects of, say, like LangChain4j, which is where one of Java's sweet spot is to be able to integrate all these AI solutions together.
True that. Well, from my perspective as a developer, it's also nice to be able to use the language features to write something more expressive when interacting with AI. Because when it comes to an expressiveness, there are a couple of languages out there that could help us to interact with AI, but that's not as close to the way that you're used to interacting. Writing code as Java does. Well, speaking about that, lots of people are like saying, why doesn't Java have something like the Python libraries? But folks, the Python libraries, they are most of the time additions to the Python itself, what is given as the basic, the language. So we also probably would need libraries, and we can make our own libraries if we want to, and soon I'm going to ask Paul to demo that. So in my opinion, I don't think we necessarily need to compete with Python. I think we can make use of what is already there in the ecosystem, because I think you told me that a lot of the libraries out there, they're written in C and C++, not in Python.
Yes, that's correct. I think a lot of machine learning libraries, including Fortran as well, going past the linear algebra, there's still people who use it. So there's a lot of people who've written very high performance, say matrix multiply or linear algebra stuff, and rather than trying to re-implement it, we can embrace it like Python does, give it a nice big hug, and so you can keep all your code in Java and embrace these native solutions. And I think that's a great opportunity. You have the choice of reaching out to native stuff if that's useful to you, but you have the choice of reaching out to pure library stuff in Java if you used to, or a combination.
That's an amazing choice. So I want to see some of that in action,
okay.
And we'd like to ask you to have a little demo for our folks and how we can interact with these native libraries using JExtract, and of course look at a little bit what code it generates, the FFM code. We're going to use JExtract for Onyx GenAI runtime, I think.
That's correct.
Can maybe set the stage a bit.
Let's set the stage a bit. What we want to do is give a nice big Java bear hug to Onyx Neural Network Exchange. Onyx is an interoperable format for machine learning models, and it's also a native runtime or foreign runtime with respect to Java for executing those models. It's really the sort of big interop machine learning model interop thing in town. And so you can think of Onyx model as a sort of constrained form of code. It's just, it describes a programming model that's effectively operating on multi-dimensional arrays or tensors like gem or transpose, and it's effectively linear algebra code in some respects from a machine learning model. And from a perspective of Java, what we can use the Onyx runtime, which is considered a sort of foreign native library, and the Onyx programming model that specifies how you operate on tensors, and we consider that a foreign programming model.
Okay.
So the Java platform knows nothing about Onyx at all, and that's how it should be. But we can teach Java to know about Onyx by building sort of libraries on top of the platform.
Sounds very nice.
With the building blocks, such as Panama.
Okay, let's see how we can do that.
Okay, so what we're going to show first of all, we're going to show how Panama can interoperate with the Onyx runtime. And later we'll show how Babylon can interoperate with the foreign programming model. And so the first one we're going to show is how Project Panama can interoperate with the Onyx GenAI runtime and run an LLM model.
So you got the foreign library first, I think, on your computer.
Yes, that is exactly right. So what I'm going to show here is how we can deploy and execute Onyx LLM model using Panama's foreign function memory API, GenAI runtime. So what I'm going to do is I'm going to show how we can use Panama's JExtract to generate bindings to the native Onyx runtime GenAI library by telling it to generate bindings for this C header file here. So what I've done is I've already downloaded the Onyx GenAI binary for my system. It includes the header file here. I'll open it up. And I've also included the Onyx runtime here as well because they both depend on each other. So I downloaded those from the Onyx GitHub release site. And so first of all, if we want to code to Onyx, we need to reach out to this native runtime. And if you're familiar with JNI, you'll probably go, oh my gosh, that's a lot of work. I really don't want to do that. It's so much work. But I just show you using JExtract, it's a lot easier to start interrupting. It doesn't mean it's easy, but it's a lot easier than it was beforehand. So we got this sort of C header file here. And we want to sort of call methods. So like, let's see, model, like so. Maybe we want to call the config model data. I'm just picking this as a C API, a C method definition. We want to call that. So we want to run JExtract over this header file and generate our Java bindings using the FFM API. And so I have a script already available that I will run. And so what it is, we call JExtract. We'll tell it what package we want the generated binding code in. We'll say where it's going to be available, and we'll give it the link to, we'll give it the reference to the header file, and I can just run that like so.
Folks, if you want to know where Paul got JExtract on his computer, because JExtract is not part of the JDK, it's not yet a JDK tool inside the JDK. Well, JExtract is available as already prepared binary. I think it's on OpenJDK JExtract. Oh, the early access builds, I was going to say.
Let's go back.
That
one.
Yeah, the third one.
Yeah.
So we have some early access builds of JExtract that you can download and play already. So we have the binaries there. You don't need to build it yourself. However, we're still improving on the software. If you want to like get the latest and the greatest and just build it for your own operating system, you can also do that on GitHub. As Paul was going the first place there.
That's correct. Yes. If you really want to be brave and build it yourself, you can actually do so too.
It's not that difficult, you know. Anyway.
Correct.
There's like a very nice README file that teaches you how to build JExtract, but also there's a nice document on how to use JExtract that I think Jorn Vernet and other members of the Panama team have put
That's
together.
right. I highly recommend reading this. It's excellent, and it gives you all of the options and explains what they are and how to use them, especially how you link to the native libraries dynamically at runtime.
We also have some tutorials on dev.java on how to use FFM and also how to use JExtract. So that is another option if you like going to dev.java and go more tutorial mode instead of looking directly into how-to guide. However, whatever option you prefer to learn, there are ways for you to get JExtract, to learn about JExtract and its features is quite well documented, I would say. Now, I will not disturb you anymore and let you run.
Let's back up so we can just run JExtract minus, I think it's minus version. So we get we're using the latest one here, but just also, of course, just let me show you that we're using Java 25 for this too.
Yeah, because, well, it's a binary, it doesn't really need like to be...
Yeah, when you download JExtract, it's actually a J-linked version of it ships with its own version of the JDK and ships with its own dependencies. It actually uses itself to interoperate with the native LLVM runtime to understand what the C code is. So it's actually eating itself in some ways. So let's go back to running JExtract here. So what we did was we ran JExtract over the GenAI, and I actually ran this, and we can see it stuck it in the gen source, and it generated...
Wow, that's a lot of code.
Yeah, it generated a bunch of stuff. There's like Darwin p-threads and stuff like this.
It only does this on Mac.
Yes, it does it on Mac. But it generated the code in the package we wanted, and let's just see. There's probably some calls to config. I think I showed this. I can't remember what I showed, but it.
Yeah, you wanted one of the functions from the
header file. Yes. So you can see it generates the equivalent sort of Java method declarations for the C method declarations. So now we got a hooks in here. I didn't have to write this by hand. So now we've created a sort of mirror API in Java that mirrors the equivalent of the C API in the Onyx Onyx GenAI runtime. But it also generated a bunch of stuff here.
Yeah.
Now when you're generating using JExtract, sometimes you want to filter out some information from either your API or ancillary stuff that this Gen AI API included through the C API. So these come in because this C API includes various stuff in its header files, and we are not interested necessarily in what it includes, especially if the API doesn't depend on it. So what we can do is we can filter this out.
And not write in the C class, right?
Correct.
No C. That's
No
great.
C.
That sounds great.
No JNI, no C at all, just pure Java code. So we can run another script instead, which we can run JExtract the first time, which it dumps out effectively a bunch of directives that tell JExtract what to do. It tells it what is it going to do over this header file, and then I can take that sort of set of directives and use just grep to filter things out and say I only want things related to the JNI directives, and then I can run JExtract again, giving it as a command the filtered directives.
The argument files.
So I can, yes, exactly. So I can just run that one instead. And let me just bash clean the prior close. So I'll get rid of that and I'll run it again so we can see the dump generate, like so. And so what we see in the gen source now is a much shrinked set of stuff. And let me show you the symbols which we dumped out. So you can see JExtract give these kind of directives or instructions. There's a function that we have to include. There's probably some structures defined and so forth like that. But there's other ones in other header files, and this is where all this extra stuff came from that we filtered out. So the filtered one that we had here, we pashed into the second call to JExtract, just contains all the Gen AI stuff that we need, and we just shrunk down our binding code to that. So that's how you sort of work in JExtract and filter stuff out if you want to, just what you need.
Nobody gets lost when regenerating their bindings, just using these
Correct.
things.
And of course, I'm doing this with bash scripts or shell scripts, and of course, if you're using Maven or Gradle, there might be a bit more curated way of integrating in.
Probably,
Maybe.
But I like a scripted way.
Yes. Exactly. So that's how we've done that. So now we've got these bindings, we can actually start coding to it. And so no JNI, we just have to understand. You don't get a total free lunch here. You have to understand what the C API is doing. You have to read its docs so you know what to call. So now we're going to code in a C idiomatic way using this C mirror API exposed in Java. So let me just show you what's going on there. Clean this up. So we wrote this ahead of time. I didn't write this. I think a colleague of mine, I can't remember his name now.
So we want to thank to Nizar Banala for putting together this demo, which is, by the way, available in the samples of JExtract, so you can try it yourselves as well. Nizar has documented that demo really, really well, so shout out to him. And I think he's going to present this demo and speak much more about this at a conference in Morocco this autumn.
So what we're going to do is we're going to run this, and it's going to, let me just show you the run script just to get a sense on what we're going to do here. So we're going to run this Java program. We're going to first of all tell it, well, I'm enabling native access here. I've got to opt in because native access is kind of unsafe. So I'm going to explicitly.
But we know what we do here.
Exactly.
So we're allowed.
We're allowed because we're saying this on the command line. I opt into this type of behavior. We're going to say where our library path is to both the Gen AI and Onyx runtimes here. We're going to say where our class path is. In fact, while we're doing that, I'm going to build the project before we run it. We're going to say while we're running, and we're also going to point it to this model file, the LLM model file we're going to execute, which is downloaded from Hugging Face. I believe this is a 5.3. There are enormous amounts of model files available. So this is an Onyx model, and it's pre-trained on a bunch of stuff. 5.3 describes the sort of categorization of how it's trained, and it's designed to run on a CPU and mobile, and it's about 2.7 gigabytes of mobile. That's quite a lot, but it's designed with a level of optimization and it uses sort of I think quantization at int4 levels. I don't understand all of what's going on here. So what we're going to do is run this. It's going to load the model, and so this Java source code is going to interoperate with the Onyx runtime, and it's going to deploy the model in the Onyx runtime and then execute it. And we can see that this code is effectively setting up a prompt template, and anything I type in when we run this is going to be substituted in this here. So basically, interoperating with this machine learning model is string concatenation at various
my God! And this is just one Java class of couple of
Yes, and so here we are
tens of
creating the
lines.
model, creating the tokenizer, setting it all up, loading the model in from memory, all that 2.7 gigabytes, I believe. And then we effectively, when we call a prompt, we are going to pass the user prompt, we're going to tokenize it, we're going to append the token sequence to a prior token sequence, and then we're going to go through until it's finished doing its tokenization and come out and finished its prompt for us. And so we can just run that directly. So this code is basically pure Java code. We've already got a lift up, no JNI code in here. We've already got a lift up with our bindings. So if we, oops, let me just zoom in here, see if I can.
Yeah, I think it.
Maybe people will see it a little better.
If
So-
you can just clean and.
Yeah, let's do that.
Oh, okay.
Bash run. There we go. So that didn't take too long to load that model in. Also, I loaded it in just before to pre-warm up the caches. So we can is Java good for? And now this could be dangerous to say this.
Oh, I hope it's going to reply something
so
beautiful.
now we're
and
running
nice.
model. We deployed the model through Onyx runtime, and now we asked it a question. And it's actually not bad. It's pretty reasonable in terms of what it's saying.
I like
it's very
its,
positive.
answer.
And one of the reasons why it might be so positive is because we sort of said you're a very helpful assistant, so it's going to be very polite.
Yeah, but it's also very.
Yep. So we can interact just like a chat, and it's very simple to sort of do this kind of thing and get started. So that's how you reach out to the Onyx runtime and deploy pre-existing Onyx models with Java.
Amazing. Now let's go to much more core stuff and complicated stuff now that we start with the simple things and how we can work with Java 25 even to have interoperability with Onyx GenAI runtime. And write so little Java code and very beautiful Java code, if I may say. That's much more readable than C code from my point of
It
view.
is, although it's kind of like idiomatic C.
Yeah.
This is not how you generally want to write. You want to wrap this API around something more
Yeah, but
friendlier.
for first,
Get started, it's great.
I think for getting started
Yeah.
is great.
And in fact, you could probably use AI code generation models to actually help you with this process if you're doing some, I hate to use the word vibe coding, but there I've used it.
You can vibe code for better.
You can probably hack this together using this to help you if you don't understand about the Onyx API and the LLM does. It can actually, and because there's a so close correlation with C, the model can probably infer enough for you to get started.
That's really, really, really cool. So now show me the next part because I'm also curious about Babylon.
All
How
right.
does that?
So I mentioned that Panama is all about reaching out to foreign or native libraries. Babylon is all about reaching out to foreign programming models, and the two combined it can offer a very powerful solution. So what Project Babylon will give is effectively access to Java code in a symbolic form, which you can then translate to foreign code. So we can take Java code and we can translate to code in a foreign programming model, such as GPUs or machine learning models. So forth. So it allows you to leverage program models directly in Java, and you don't have to write different code, possibly embed code in text blocks, foreign code, and so forth. So you can think about C#'s link feature, but on steroids. So what we're doing is
I like that.
we're playing with Onyx and ensure that Babylon's features are fit for purpose, and address the pain point that it's kind of hard to develop machine learning models in Java. It's kind of too difficult. So we're exploring this space to see if we can make it easier.
Been there, done that in my youth.
So what we're going to show, first of all, is we're going to develop a simple sort of convolutional neural network machine learning model in Java. We're going to export that model to Onyx, and that's a foreign programming model. And then we're going to execute that Onyx model using the Onyx runtime, like we showed executing before. So we're going to sort of up-level the sort of coding experience here. And so Babylon's code reflection feature will enable a translation of a machine learning model to Onyx model, and Project Panama's FFM API will allow us to export and execute it. And this time we're going to use JExtract to actually focus on the Onyx runtime C API instead of the GenAI runtime.
Yeah, they're different.
And the weights we're going to use are pre-extracted or obtained from a pre-trained model, effectively. So we can flip to the other project here, so the MNIST demo. I'm just going to run it first of all. So what this demo is doing is the classic demo of predicting what number is in an image. So we can now
use your best skills for drawing.
You know what? I think I've got a problem here because the shift key is absolutely disabled on when I'm doing
presentations.
There we go. Yes. Sorry. There we go.
Oh,
So yeah, there was a problem with the display sometimes interferes with the keyboard. So what we implemented an application. It predicts numbers. It sends this image off to the model executing through the Onyx runtime, and it comes out with a probability number, and a probability that says that the number 7 is the highest here, and so forth like that. So you can try again, like sort of, let me do, I'm terrible at 8s. So that will probably get it wrong, and it's confused between a 6 and an 8.
Yeah,
so
it might be a 6, might be an 8.
Yes. So what's going on here? So if we look at the code, we have implemented the convolutional neural network in Java basically as a code that operates on tensors in the image. We operate on it in a bunch of layers using standard sort of operators that people are familiar with in machine learning, like convolution, ReLU, maxpool, and so forth, gem, matrix multiply, and we do a bunch of layers, and then out pops our predictions. So the input here is an image, a tensor of all of the data points in the image, about 800, and when we output 10 data points out corresponding to the probabilities of number. But we coded this in Java, and then we translated this Java code using Babylon to an Onyx model, and then we deployed it to the Onyx runtime and executed it.
That's very impressive. The code that you're showing here, this example, is also available in the Babylon GitHub repo. You can try it yourself. The only thing that you need to do is actually to build the project Babylon, because that is an, let's say, extended JDK of the current main. The current mainline JDK is actually JDK 26. The early access build of JDK 26 is nowadays.
Yeah. So we're actually ahead of the curve here.
Yeah.
Yeah.
Yeah, you started quite early. I saw when it shifted.
Yes, exactly. So we're using 25 plus more.
Yes. So you can try this one as well. I tried it. I went back to Paul. I was like asking, what does this do? What does this do? More like Dexter Laboratory kind of thing, DD. So that's really, really impressive and cool. So this is the part of code reflection of Babylon, right? But you mentioned also HAT, and I think Chad also mentioned the Heterogeneous Accelerator Toolkit. What can you tell us about that? Because maybe folks are finding working with this a little bit difficult, or like not what they're used to as Java developers. So what HAT can bring to the table and help us?
HAT, Heterogeneous Accelerator Toolkit, is the second part of Project Babylon, which is what we're doing is we're exploring GPUs. Just like we explored machine learning models in Onyx, we want to ensure that Babylon's features are fit for purpose and can solve the pain point that it's just too difficult using Java with GPUs. HAT can provide the infrastructure to implement machine learning models in Java. If you want to do that instead of using a native runtime, Onyx runtime, we could actually implement these operations I showed before using GPU kernels, and we can use HAT to implement those kernels for us in Java that compile to GPU code. So HAT is a library that's built on top using Panama to reach out to the GPU compiler and GPU runtime, and using Babylon to reach out to the GPU programming model. Exactly the same way for the machine learning models, but a different use case. So HAT is really providing 4 things. One is a kernel parallel programming model familiar to GPU developers, a compute programming model that scopes your computation and coordinates calls with GPU kernels, a data model for interacting between the Java side and the GPU side, and importantly, a pluggable accelerator abstraction to allow you to plug in implementations to perform the translation from Java code to, say, CUDA code or OpenCL code.
That sounds amazing, because I think HAT will be looking like, if I'm looking at it, it would be like a wrapper, like a unifying the way that we can interact, that we don't need to like code in, I don't know that much about OpenCL or CUDA, and
yes,
just focus more on making something expressive in Java. But of course, knowing a bit on how to work with
yes,
the GPU.
You're going to have to know an understanding of how the GPU architecture works, especially its memory hierarchy and its the way warps work and so forth.
But it will look much more beautiful and expressive.
Yes.
I have friends that work with CUDA and not necessarily fans of it. But then I was telling them we're looking into this, and like, I can't believe that. That would be amazing, because it would be a language that would be more beautiful to work with.
If we can pull this off, all Java developers can become CUDA developers without knowing it.
Oh God, that's a good market there.
Maybe that's the case.
That's a very good market there.
That's one goal, is the ability to write portable Java code can run on the CPU or on a GPU. It's quite challenging to make that happen, but we're exploring this space, and we want to make this a reality.
Do you have a demo for that?
Yes, I do.
Yes.
So I'm going to show a game of life demo. So we implemented effectively, let's see here. Let's just go up here and let's show. So this is the game of life algorithm written in Java code. It's slightly a little weird Java code, a little bit, just the way we've defined the contract of how you're writing Java code that gets translated to GPU code. But this is effectively the algorithm for the game of life, written in a CUDA-like model, but written in Java. And what we'll do is we'll take this code and we'll translate it to OpenCL code, and then we'll run it on the Mac, like so. So first of all, I am going to run it on the Java multi-threaded. So it's not going to use the GPU, it's just going to use the CPU. And what we did, we loaded it a lot. You can write programs in life, and this is a program to simulate a digital clock. And so it's running through the life system, and what you can't see, because it's running about 7 frames a second, is eventually you'll see the digits appear here if we wait long enough, but we don't have enough time. So we're going to quit that, and now we're going to run it what we're going to do is going to take that code and we're going to run it on the GPU by translating it to OpenCL C code instead. And so we're going to run that driver, and we'll see we've already gone up to about 40.
So running this on the GPU is actually, we're going to see results much faster than running on the CPU.
Yes, wow. But we can get a bit better here. We're not being smart enough. Like I said, in one part of HAT is a compute programming model that encompasses how we call kernels. And that allows us to optimize the movement of data and allows us to optimize the scheduling of kernel execution. So we can get a bit faster, because what's going on here, every cycle we're displaying an update to the user on what the state of the life model world is, but we can actually run the GPU faster and display at the same time for user perception, so we can actually iterate through the life faster and take samples of the snapshots instead. And we can actually do that by enabling a feature where we minimize the copies. Is that good?
I was going to say, can I see the command again?
Oh yes, let me do that again. So I'm running HAT and I'm asking it now, turn on the minimize copies optimization. And we're going to, I'll talk about the show code after that. And so let's start that, and we should see an increase here.
Oh, wow, yes, much more faster.
If we go running out of time here, but if we keep talking, you'll actually see the digits sort of come, and we can almost see them appearing now.
Yeah.
So what's happening? HAT is smart because we don't need to show every frame of the world of life. We can show it every sort of 50 seconds, but behind the scenes, it's computing way faster. Like so, and we just optimize through copies, because we only need to copy when we need to, when we're ready to show, rather than every single time. Now we see it's the digit starting to 12 and the PM is coming up, and so forth like that. Now let's just have a look at the code here. So what we translated our Java code to OpenCL C code here. So here's the equivalent sort of kernel we translated under the covers, and it looks like happens to look like idiomatic C code. If we formatted it, it would make it look easier. And we can see that also we generated some structures with here which correspond to the data model I talked about, and so forth. So you see we've already got a pretty good way of translating Java code to OpenCL C code, and we're using Panama to interoperate with the GPU to compile this and then execute it.
Impressive. impressive. Thank you, Paul. Thank you for putting together all these demos for us and for explaining it and in like layman's terms so that we all understand what you're working on. Thank you again for being here with us today, folks. We're going to hand over to the last part of our live stream where Billy has a special guest talking about the future of Java most probably. And well, Paul, once again, thank you for inspiring us. Java is for AI. So keep in touch, stay tuned what's going to be developed next. Billy, next to you.
All right, thank you, Anna. Thank you, Paul. That was super interesting watching that about all the promise of AI and how we're actually working on to incorporate that into the Java platform. So I'm here talking with the head of the Java platform. I believe Nicolai, who is just off camera here, referred to you as the CEO of Java. Is that a title that you still claim? Or
oh, wow. I don't know
no
if I ever claimed that, but...
So one of the things I did want to talk to you about, though, is, so Anna and Paul were talking about Java and AI, and then kind of during their presentation, they were going through kind of referencing things like Panama, Babylon, Valhalla to some extent. So how do we go through and kind of decide which projects to work on, and how does that kind of go?
Yeah, that's a great question, Billy. Thank you. So, obviously, with some of these projects, they've been going on for quite a while. And so, I'd love to say that, back in 2014, 2015, we were like, oh, yeah, in, 9 or 10 years, like AI is going to be really important, so we need to do these projects. But it turns out that what we were doing at that time was sort of looking at where, the sort of general trend that we thought was going, both in the capabilities of hardware and software, but also in how people wanted to program and the kind of workloads that were becoming popular as the capabilities of our technological environment improved. And so what we looked at was, well, we see sort of one trend where people are trying to do things where they're sort of processing more and more data, right? But also they have transactional systems that they want to be able to respond, very swiftly, not have a lot of latency, and that kind of thing. And then, on the sort of the complete other end of the scale, there were people who were looking at ways of breaking programs apart into sort of smaller bits that would interact and that kind of thing. What we now know as microservices. So basically, what we tended to do is sort of look at where do we think, real tough sort of self-examination, where do we think the Java platform is in helping developers sort of answer those challenges that were coming along? And we found a bunch of areas where we felt there were things we could do to make it better, and sort of anticipate capabilities coming along and find ways of making those available to people, not only for their Java programs that they're writing in the future, but also for the ones that they had today, and kind of moving those into the new world. And so that's really where we got started with some of these projects, right? When we started, Panama, it was sort of recognizing the fact that making calls between Java and native code was really tough. It was error prone, it was slow, it was hard to maintain. And so that's, we thought that was going to be important, and so we worked on that. Same kind of thing when we looked at, for instance, Babylon and now HAT, it's sort of recognizing the fact that these facilities like GPUs were coming along, farms of GPUs, how do we help Java developers take advantage of them? And there we saw that some of the challenges developers faced were, gosh, there are these different ways of doing it, and I don't want to have to write them 50 times at this very, very low level. I'd like to write a high-level algorithm and have it work, figuring out what my runtime environment is, and just making it work. And that's something Java has been great at, and so that made sense for us to target as a future capability for the Java platform.
And that's so important, especially things like GPUs and some of that technology. It's moving so fast that if you had to completely rewrite your high-level programs to do that every time, that would be a significant impediment to it. And it's also kind of interesting, because some of this stuff, AI, obviously AI has been around for a very long time, but it really started to take off at the end of 2022 when ChatGPT was released.
And even before that, right? Years before that, people were doing big data. And then it was kind of ML, and then it was AI. But it's sort of kind of morphing in some way, the capabilities, really sort of the same kinds of things required, right? But if we had sort of started off way back then and said we can only like focus on this one little thing, that might not have been as broadly applicable and useful.
Yeah, exactly. And so, I mean, that's one of those things. It's not like, we're not really as reactive to the stuff as it might kind of seem sometimes, but it's more like we were starting these projects, kind of seeing some of these capabilities, either emergent things because of new hardware capabilities, or maybe new emergent practices kind of a little bit further downstream from that to better take advantage of it. And so like we were already starting to work to that, and then some of these things then end up becoming very important to things like AI or whatever it might be. So I guess we didn't really talk about this too much beforehand, but how even early on do some of these projects really start? Like, for example, one of our newer projects is Leiden. How did that even kind of come to that? Is it just the JDK engineers that Brian Getz or Mark Ryan will come in to say?
No, I would say that something like Leiden, again, that's a similar thing, right? We knew many years ago that lots of Java developers would love to see better startup and better warm up. For us, there are so many of these kinds of things that we would like to be working on, but we are the team we are the community we are, and we can't do everything at once. Many of these things actually do interact. So sometimes it's a question of you need certain sort of foundational capabilities in order to sort of tackle the next level. And that's not always easy or obvious to see. Sometimes it's simply a matter of, well, what's the thing that's going to be most impactful to people now versus, well, I guess we could wait another year or 2 or 5 for that other thing. So those are some of the things that we look at in terms of timing and prioritization of what we're investing in. But I think that we try to look at things and do them sort of step by step. So it's sort of, this area, it feels like there's something there. We need to do some research and figure it out. And so a lot of the projects that we run don't start out as a project to implement a feature. They start out as a project to explore a problem space and really kind of understand what are the real issues? Are there underlying capabilities that are needed? Right? And what are some potential solutions? Can we try those out? Can we implement them? And then the really, really hard part, I think Brian Getz called it the descending from the peak of complexity. Right? Is often you come up with something, you come up with a solution, and it's very, very easy to just fall in love with your solution and not realize that well, it really could be better. But it's sort of like the old adage of the .sig file. If I had more time, this email would have been shorter. Well, okay, that's how these projects are. What we find is that when we spend the time to keep looking at them and not be satisfied with the first solution that came along, we often find that they get better and better. And often what happens is they get simpler. Right? And you can really see the interactions with other things. And we, for us, we want to add features that feel natural, that feel like a part of the platform, that don't feel like something bolted on the side.
I remember, I think that was about last year, I think it was at DevOps BE Belgium when Brian introduced that talk. I think it was sometime around then. And I thought that was a very interesting talk because it also kind of talks to the somewhat unique space that we're in here. Because back when I was, actively working on development projects, so often, only you or a very small number of other developers would ever really interact with that project. So, it's hey, you get your first solution, sometimes you go back and refactor it, or sometimes you get years later when you realize that you go back to refactor it, but it's never quite as a high priority. It's never really, really important to really make sure it's super usable. But for us, because we have millions of Java developers out there, that those unique cases are going to be out there. Are also, there's going to be the cases that if we do something a little bit wrong, and then we're going to have to maintain it forever. I mean, serialization again is kind of one of those examples.
Right. It's both of those things. It's both the breadth of use, the fact that it's all kinds of use cases, right? And I think it's very easy as a developer to sort of look at something like Java through a lens of what I need, right? But it's also what everyone else needs, and that can sometimes be a very hard balance. But I know everyone would love to have more features more quickly. Well, except for enterprises who just want stability.
Yeah, exactly.
But I do think that over time, people have come to appreciate the approach that this team takes to really not being satisfied until something is good. Is good enough. The way that we've found to be able to deliver things incrementally, I think has helped. Right?
Yeah.
Because we do see constant progress and progress towards a goal, and even more the development being done transparently the way we do in projects in the OpenJDK community. I think that helps too, right? Because you can look at those, you can see how far along are they, what kinds of discussions are being had, and kind of gauge, how close does this feel?
Yeah, and I think also one of the things is, just earlier this year we celebrated our 30th anniversary, and so to me, I also take we need to take a longer view. Like for example, I was really looking forward to the new structured concurrency API. I was really I knew it wasn't because I knew I was following the EA and I knew that they're going to introduce a new API, so I knew it was going to be finalized in 25. But it's oh man, it would have been really nice because obviously a lot of developers are going to end up on 25 if that made it. But you know what? It's better to wait just a little bit longer to make sure that they get that API right, because there could be some edge case that just isn't really thought about, or maybe something that was thought as an edge case that is actually a much more significant case, and then it's just oh, we released it, we wanted to get into 25 or something,
late,
and then now it's stuck forever, because I think it's once you make something public, you kind of have to support it forever, and that's
and it's interesting, right? Because we are in an industry that moves fast, that really prioritizes delivering quickly. But again, I think an interesting thing about that is different sort of levels of technology, it may be appropriate to value different things. And certainly for the Java platform, we value innovation, but we also know that people rely upon us for delivering stability. And I think that's something that you see more and more. We see all of the sort of new things people are excited about, and then when they're trying to take it to another context and take it to the next level, it's oh gosh, maybe the technology it's on is not really appropriate for my new usage. So we like to think that Java is appropriate for a lot of people really using it for real for just about everything, and we want to keep that reputation.
And like I said, that does it, is that we do try to be a general purpose language. We do try to cover things. We cover things from doing front end development with historically things like Swing, and even before that AWT. But now we also have Java FX, which we continue to support, even though it's no longer part of the JDK. Of course, server side programming is huge. That's where my history and my background comes into. But then native development, I've listening to Paul and other people talk about native, I'm that's cool. I've never done that before. So we are covering a lot of use cases, and it's important that there isn't some sort of jarring line between it's oh, okay, if I'm switching to native development or going to front end development, that all of a sudden it's a taking on a completely different programming paradigm or something like that. So it's not easy. It's
for sure.
And I think also one thing that also helps as and this started all the way back with James Gosling, is the Java's last mover advantage, that we kind of look to see what other languages are doing, and before we immediately jump into that. Let's see, what else is there? So we also have plenty of other projects going on. We had things like ZDC, which we talked about earlier, and that's continuing development. So one of the big changes, we just have generational mode now, but GDC and the other ones, there's a bunch of new features coming up for it. Loom as well. Let's see, I think there was,
And even in addition to that, right, I think we started off the day with Mikael Vidstedt talking about, performance benefits you get just by, moving up to a new version. Right?
That was. And it was also kind of nice because actually between 17 and 21, so we talked about earlier how we did a series of videos from covering Java 21 to 25, and we did similar videos from 17 to 21. In that case, I was remember looking at some of our internal testing for performance, and wait, am I seeing this right? It's the performance difference isn't too significant, but for this one from 21 to 25, we saw a really pretty good performance, but improvement coming from it. So that's oftentimes some of the big advantages for enterprises is not, the new performance features are not the new language features will keep the developers happy, but the new performance features that'll keep the accountants happy because bring down that cloud bill.
Yep,
perfect. Sure. Yeah, so another thing that we've been talking about a few times here that's going to be coming up again is Java 1. So yes. Yeah, so that was super successful last year. I'll admit, I was nervous at times about Java 1. I mean, putting on together a conference is a lot of work. It's a lot of difficulty, but it was really successful. Like I was really happy. All the attendees were happy. So yeah, like, what are we hoping to do with this upcoming Java?
I thought, like you, I thought Java 1 was great. I was also, was curious to see how it would go. I wouldn't say I was worried, but I would say that, no,
I'm a natural worrier, maybe.
Well, I mean, so there were a lot of things that were new, right? It was in a new place. It was a little bit of a different format. It was very much targeted going back to our roots of being a very technical conference. That was really, sort of almost boutique, right? In terms of the experience that we wanted people to have. And I think the great thing about that is that, the feedback that I got from people who went was that they felt like they got that experience, right? They had a chance to hear about the latest technologies from the developers who made them. They got to interact with them. They got to interact with other developers like themselves and kind of learn from people's experiences. And I think it's really important that Java 1 be that kind of experience. Right? While we actually did hold it here on the Oracle campus, it was one where we had sponsors from around the industry, where there were all kinds of people that are taking part, both in making tools and libraries and IDEs and all kinds of things, but also working on other distros of Java. So and contributing to the mainline through OpenJDK. So I think that was a fantastic experience and a great chance for people to meet and make contacts. I think going forward this year, we're going to want to see even more of that. And of course, everyone is going to be talking about AI and be talking about the projects that we have and the kind of impact that they can make on AI. I actually saw a post on a social media network earlier today where someone was predicting that in 2 years, people are going to be amazed just how much AI is going to be, choosing Java and the JVM as their runtime of choice. And I think that makes a lot of sense based on the things we're talking about today.
And I think to that, Joe, maybe go back a little bit to that, because we've seen so much from AI over the past 3 years, and obviously Python has been definitely one of the most popular languages for doing a lot of that work. But I think it's also, we're still very much in the early days of AI. Like it might seem like, oh wow, like this is what it is, but there's going to be getting to that point of some of the current approaches and technologies, our techniques, is going to maybe have diminishing returns, and there's going to be that next approach, and that could be the opportunity where Java could also excel in, because it's like cloud services and cloud platforms, like they started taking off in like the mid 2010s, or not the mid 2010s, the mid knots and like later part of the knots, and so it's like, oh wow, almost 20 years later, but still there's a lot of organizations that are still working towards migrating there, and I'm sure that's going to be the case with AI, that there's still a lot of runway left.
I think that's right, and I also think the other thing is there's so much so many business applications and infrastructure that are out there that are written in Java. And what they want to do is take all of that that's running really well and integrate Java into it. And so I think we're going to see the kinds of qualities that have made people value Java for those mission critical areas. They're also going to be important for AI as it's really getting integrated in what everyone does.
Fantastic. Well, anyways, so Java 1, that is going to be the 17th through 19th, is that?
Of March.
Of March.
Yes.
So come here. So it'll be actually again here. Probably not too many people going to be physically in this location, but it'll be a chance to meet George, myself, Anna, Nicolai, and a bunch of other people. You're going to be able to finally get to see a bunch of us in person, ask us questions and all that stuff, and leave, hopefully positive feedback as well.
Not that many, right?
Yeah, exactly. But anyways, thank you everyone for joining us on the Java 25 launch stream.
Bye.
Are we still on? Woo!
You didn't do that.
No, I did. That was intentional.
High five.
There, perfect. Thank you.
High five. More high five.